Hello, welcome to another stream. How about that? Welcome, welcome, welcome. Hello, Ekorabol, hello, Out9, Hamikovi, Hudson Plots, Igudu, Go on the Third, Shigiman, Yatanasov, Serimun, Hudson Plots, hello, hello, Sasala 23, Iguduk, hello, hello, welcome, welcome, welcome. So today is Tuesday, I think, if I'm not mistaken. I'm pretty sure today is Tuesday. That means today, according to the schedule, we're supposed to be doing virtual machine, but debated yet again. I want to continue doing OpenGL. Yes, today is probably going to be the last OpenGL stream in this series, right? So because we studied this series of 3D graphics in OpenGL to explore how to do 3D graphics in OpenGL. Probably today's stream is going to be the last in the series, but it's not going to be the last OpenGL 3D OpenGL stream in general, right? So this kind of like journey gave me a couple of ideas for future projects. So we'll see what we can do with it. Maybe eventually we're going to start like our own 3D engine. Who knows? Maybe all of that will evolve into something more interesting. So yeah. Today, I want you to finish the last point in our objective and implement some sort of lighting. You can find the source code of what we're doing here, right here. And yeah, let's just jump into it, I suppose. So where is the source code? It's called Kidito, and I did a couple of changes off screen. Specifically, I removed loading mesh from the external file and switched back to generating it procedurally at runtime, because I figured that for our specific goal, you know, having external file for mesh is a little bit of an overkill, right? And on top of that, OBJ file format is not particularly flexible, doesn't actually enable us with everything we want to store there, so that means we don't get any benefits of external tools if we use custom formats, so might as well just generate everything at runtime, so whatever. Yeah, that's basically what I did. Apart from that, everything is the same as far as I can tell, as far as I can remember though. So let me start this entire thing. So here it is. So we have this cube, this meta cube where we use this is, by the way, very creepy. It looks like some sort of like yeah. This is like a nose with two huge nostrils, and this is the eyes. Yes. Nice. It's very, very fucking nice. What I wanted to say. Yeah, we introduced hot reloading for textures as well, and also introduced the configuration file that describes the scene, right? That describes the current scene. So let's go to the KD tone, and so where is the scene? Scene conf, right? So in scene conf, at any point you can, for example, switch to something else, yes, and hot reload this entire stuff. So yeah, that's pretty cool. So, and you can also switch the paths to different shaders, but it's not particularly useful right now. So yeah, so we have a special configuration file which is also hot reloadable. So first, the first thing it does, it hot reloads the configuration file, then it looks at each of these paths and hot reloads each of these files correspondingly. So just like top-down traversal of some sort. So yes. As you can see, what are the objectives? What are the objectives that we had? So the first objective was to generate the cube mesh. We generated cube mesh, rendered the cube mesh with the perspective projection. As you can see, this does look like a perspective projection. We textured the cube and we implemented the fog. You can clearly see the fog. Or see, the farther it away, the more foggy it looks. And the last objective is the simple lighting, the classical one with normals and stuff. Essentially, for each vertex, we're gonna associate, or maybe edge polygon, whatever. So let's assume that with each triangle, we're gonna associate its normal, facing outwards. And then we have the direction of the light. And depending on the angle between the direction of the light and the normal, right, we're gonna color corresponding pixels differently, right? So yeah, that's gonna be the pretty much everything I wanted to implement. For today, I'm not sure how much time it will take. That's why I'm assuming that it may take the whole stream, because I'm a PPG developer. So the first thing that we'll probably need to do, we'll need to generate the normals, because right now our mesh doesn't generate them. We only generate the vertices and the textures, right? So we just need to add an ability to generate normals. Once we generate them, we'll probably need to see how to pre-process them and stuff like that. We'll see. Let's just first generate the normals and see how it goes. So I'm gonna go to the geo.c, and this is where we generate the mesh. Where it is, generate cube mesh. So right now we generate the positions, the colors, and UVs. Chat is pretty dated. We only started the stream. What do you want? And furthermore, this is an educational stream, not a shitposting stream. We're here to learn something new. Alright? Okay. Don't you want to learn something new about 3D graphics? Zoizin opened a PR. Don't hate me. Why would I hate you? Why would I hate you? Let me take a look at your PR. Is that like a serious PR, or is that a joke PR? I need to go through my PRs. Oh yeah, I do remember. Recently, GitHub actually fucking logged out me from all of the things. Okay, so just a second. Did it log out you all too? Like, why the fuck did you do that? Like, it's so goddamn annoying. For a second I thought that maybe I was hacked or something, but it's just, oh my god, GitHub. So what is my username? What is my password? Does anyone remember my password? Don't remember my password. I think that's my password. Hell yeah, this is my password. And also I have two-time factor authentication. And okay, so are you gonna send me anything? And it doesn't send the message. Doesn't want to send the message. Doesn't send the message. How am I supposed to log in? I have no idea. I have no idea. So I'll probably just have to wait. Are you gonna send the message or not? Why did I switch to the authentication? You can hear it. You can actually hear the message. And it still didn't come. It still didn't come through. Nope. Doesn't wanna send me a message. So that's really weird. So can I send it one more time? Resend the code. Okay, so I'm gonna request to resend the code, and guess what it's gonna do? It's gonna send 2 of them. Of course, yeah, now it's gonna send 2. Thank you so much. Oh, I fucking hate computers. Okay. 523. All right. So finally, yeah. So here's the second one. Thank you so much. Fucking like every fucking time. This is so pepega. Right. You wait like for a half of an hour. You resend it, and then you get 2 of them, as fucking usual. All right. So let's take a look. Let's take a look. Sorry? What are you sorry about? Did you log me out of GitHub? Change window title to Kidita. All right. Oh yeah. Okay, this is a result of copy pasting code. I see. Well, I mean, I'll have to log in into GitHub anyway, so it's kind of. All right. Looks good to me. Thumbs up. Thank you for your contribution. Boom. Merge the pull requests. There we go. Feel free to add this pull request to your CV. That's right. Done. Okay. Let's continue. Holy shit, I have so many pull requests to go through and depend the bot and stuff like that. God damn it. Alright. So, what I was doing, I don't quite remember. So, Kidito. Depend the bot, yes. Oh yeah, we need to now specify the normals. I suppose we're gonna start the normals per vertex. I'm pretty sure in 3D graphics programming community that joke was made so many goddamn fucking times. But yeah, we're gonna start them per vertex. Okay, I'm new to this kind of stuff, okay, so that makes me giggle a little bit. But we're gonna start the normals per vertex. Now, depend the pog. Essentially, you have a triangle. Right. Imagine that you have a triangle. Right. At some particular perspective. And yeah, so for each vertex, we're gonna have like a normal going somewhere, right? And then in the vertex shader, we're gonna pass those normals to, yeah, exactly. We're gonna pass this normals to the fragment shader, which will interpolate all of that, and then we can use that to light fragments of the triangle. That's gonna be the plan. Pen Island, yes. Haha. Yeah, there's a wolf face there. Yes, it's a very sad ooh. It's the saddest ooh I've ever made. The question is how we're gonna do that. That's a good question. As Vertex. Oh, yes, your nickname MJ Vortex. I suppose that's how it's supposed to be pronounced. So we have to. So the normals are gonna be like. Do they have to be 4-dimensional or 3-dimensional? That's a good question. Probably. It just depends on if we want to transform them and whatnot. And I suppose we do want to transform them, and in a perspective correct way, right? Because we're going to be moving them along with the vertices. Well, when we transform them, we all need to scale them and whatnot, but yeah. Okay, so let's actually generate them into D. I mean in 4D as well. So we have triangles per cube, right? Here's the triangles per cube, and this is how many vertices I have per triangle, right? So, so here we are generating the face. So this is XY face. And the first one, yeah, we need to consider how exactly we're generating things. How exactly we're generating things. So I already have my paint open. All right. I never generated normals. Look, I do a lot of these things like for the first time. Okay, so this is gonna be X, Y, Z, and this is gonna be the negative Z. So this is the positive, negative, and so on and so forth. This is really scuffed. All right. Finally found a real programmer on the Twitch platform. Real. How do you distinguish a real and not real programmer? I think not real programmer is programmed in Unreal Engine. Is that what you mean? I don't understand. A real programmer. What's the criteria? What's the criteria? Complex programming. Imaginary programming. Well, subset who? Okay, so first thing we generate the face on XY, right? So this is gonna be, so here's the first face, and in case of XY, right? Okay, I'm not gonna continue spelling. So the normals should be facing to basically Z. Ah, that's very interesting. So that's cool. So, and for 0, it's going to be pointing to like a positive direction, and for 1, it's going to be pointing in the negative direction. Correspondingly, if you generate, for example, X and Z, right? If you generate X and Z, in our case, it's going to be something like this, like X and Z. We're actually generating it like that, yeah, X and Z. This thing is gonna point negatively in Y. Okay, that's actually quite perfect. So we have the pairs of vertices. So this is the plane XY plane, ZY plane, XZ plane. And these are the axes of the normals that we have to generate. And I think that's gonna work relatively well, if you ask me. What is going on in the chat? By the way, I removed 40 characters limit on the filtering, so now, and I kind of regret it, but I think it's still worth it. So yeah, now you can type as many characters as you want. So I'm trying a different approach to the cock filtering, right? So the cock filtering is going to happen slightly differently. It's not going to be based on the length of the message anymore. So All right, all right, all right. So here we generate the colors and we generate UVs. Triple wrapping, I think this is a bad idea. Move to separate method. What you're talking about? Bike shading. All right. So X and Y, right? So yeah. So then we are taking, iterating through all of the triangles per face, and then each vertex per face. Right. So this is the pair component. So the normals. All right. And suppose normals we can actually do something like this. Count plus k. So how many hours? So you've been bugging me yesterday stream. You can keep bugging me with bike shading for the second stream. So in that particular case, I think around 2 hours should be enough for you to finally get educated. So 2 hours. One more time and you're permabanned, seriously. Okay. Okay. So I'm thinking it would be kind of better. So we're generating the cube mesh. It would be better if we could just easily push things into the containers and stuff like that. Now I need to recover my entire mental model because I got distracted. Of course. So so here is the face pairs, right? So the face pairs. And if I take a look, so it would be kind of nice to have face pairs. So this is the current face pair, right? So this is the current face pair that we're looking at, and then we're looking at the pair component, and the pair component is probably going to be used for the current pair. I would like to rename maybe I and J and all these indices to something more readable. So maybe I'm gonna rename it to just cube pair, right? Cube pair. And by cube pair, by the way, I mean so if you have a cube, it's rather like a face pair, right? So if you have something like that, right? So it's gonna be something like this and something like this. So the pair is basically something like this. So this is the like one pair. So another pair would be something like this. So this is gonna be another pair, right? So and I'm iterating through all of the pairs in here, as you can see. I don't know how to better call them. So this is another pair, right? So I'm just iterating the opposite pairs. And that's what I mean when I say pair, right? But like face pair, opposite faces. Yeah. So for some reason I call it cube pair, but which is probably all right. So cube face pairs. All right, so we can call it face pair then. So this is a face pair, face pair, face pair. Right, now let's go through the compilation errors. I don't enjoy memory safety. That's a very bold statement. Alright, so we need to actually add oh, nice. That's very interesting. And it keeps going. It generated like 7,000 lines of errors. Nice. And you know why it did that? Because I forgot a semicolon. Yeah. Fucking 2021. Imagine, okay, I'm removing semicolon, right? I'm literally removing semicolon, and there you go. It keeps going. It just keeps fucking going. It's not even C++. People, it's not even C++. We're talking about C. This is C. Pure fucking C. Holy shit. You forgot a semicolon. Good luck. How many, like, 8,000 lines of error messages. Not even templates, it's just like, holy fuck. Ooh. Why do I need to do this? Here it is. Here's the amount of lines. I can clearly see it. So, that's the new template error. I see exactly. All right. So, holy shit. Okay, generate mesh, and we also have to provide the 4 normals. Alright, trees per cube, 3 vertices, and we're gonna zero initialize this entire stuff. I'm not sure if it would be nice to have that on a stack or in a static memory, or something. I'm not sure. But yeah, we'll also have to provide the normals here as well. And is it working? It is not working. Oh, because now I replaced I with face pair. So can we replace, I can probably go like that. So here's the face pair. Face pair. So we already have face pairs and face pair. Maybe just call it face pair index then. Face pair index. There we go. So maybe we're gonna do the Casey style for loops, right? The classic. My for loop becomes too long, so I split it in 3 lines, and of course that means I stole that idea from Casey Muratory, right? Every time you split in your for loop in 3 lines like that because your for loop is long, you stole that from Casey Muratory. Yes, you did. Even if you never heard about that person before, if you never heard about like Handmade Hero, you stole that from Casey Muratory because you watched too much Handmade Hero. That's the drill. You cannot, it's a patented technique of formatting for loops. No one else is allowed to use it, except Casey Muratory. Yes. Anyways, so what are we doing? Yep. Theft. Yep. Yep. Anyways. I'm sorry, Casey. I'm joking. I love Casey. He's a good programmer. I'm just joking, of course. I'm making fun of some people who are like because I had those people several times already. Like, they look at my code. Oh, you inspired by Casey? I see. Oh, split the lines. Oh. Okay, normals. Okay, unused normals, and I need to remove this code. Fuck that code. Fuck that code specifically. Okay. Alright. Oh fuck. Oh shit. Oh fuck. Oh fuck. Oh shit. Okay, so this is a unused variable. Cool, very cool. So now we have a face pair index, and Now we have a pair component index and so on and so forth. So here we trees per faces. So I also want to rename this thing a little bit. You know, let's steal the idea from Casey. Let's actually keep it like that for now. This one is gonna be pair comp index, right? Pair comp index. Pair comp index. And do we use pair component index in here? So here it is. Pair comp index. Pair comp index. Where is the other J? Pair comp index. All right. So this is a face color. Oh, and that's very interesting. So this is a face colors. And in here, I probably have to use like a pair comps. Yeah, pair comps. There we go. Pair comps. No IJKLM. My dog is running around naked. What's funny is that 5 years ago, I thought my office job was hard. Well, I didn't expect what's gonna wait me in 5 years. Except I'm knocking on the door. Holy shit, okay. Yeah. So pair components index. Hello CPP coder. Did you know that C++ coders are not allowed here, only pure C coders? You don't have such preparedness on office, right? Yeah. Anyways, what I want to do, I wanted to actually change this shite a little bit and essentially make it two-dimensional, right? So it's gonna be something like a cube face pairs, and for each is the pair comps, right? And then here we can do something like this. Yep. There we go. Boom. Can your Wim do that? I guess he doesn't. Yes, I do remember you. I do remember you. And to prove that I do remember you, how many hours? Is 1 hour enough? Maybe 2 this time. I think 2 this time is gonna be a little bit better. So I'll let you decide, CPP coder. How many hours do you want a timeout to, you know, because you want to make sure that I remember you. Okay, so 2 hours should be enough. Okay, next. What do we do? So this should be a little bit easier to work with, right? So pair components. Who was that? I have no idea. The only thing I remember is that I timed them out before for something stupid. Let me see what I timed them out before. Okay. Yeah. Oh yeah. All right. Yeah. Okay. So they were trying to start like a editor war or something. They timed them out, and their first reaction after being timed out was this, and then they got timed out yet again. So yeah. Okay, so the last time I timed them out was 2 hours. The next one is going to be 3 hours then. So I do remember that person, of course. So the next one is going to be 3 hours until this person will finally behave. Until this person will start behaving properly, we're going to just increase the time out. Yeah. 2, 4. Maybe we can do that in a like exponential progression. Yeah, I think yeah, that's a pretty good educational method in my opinion. All right. So here's the pair components. Here's that. Then for each trees per phase, right? So here we are iterating the trees. Oh yeah, so here's the phase pair, so the current phase pair, and within each pair, yeah, so there we go. Wouldn't it overflow faster? Nah. So the more you time out, the less they will type, so the more rarely they will even type anything and get time out in the first place. So it doesn't really work the way you think it works. Jiayang, what's up? What's up? Hello, hello, welcome to the stream. How are you doing? How are you doing? Really glad to see you. 10 out till the end of the universe. What's the maximum time now? Markovian trolling. I see. What is that? I never heard of it. What is Markovian trolling? For -1. It's basically gonna underflow and it's gonna be the maximum int. I see. That's pretty good. I'm a little bit hungry, not gonna lie. A little bit hungry. Okay, so this shit compiles. So the next thing we do, tree. So we're iterating the triangles of the face, right? So this is the triangles of the face. Triangles of the face. And what's interesting is that we have to do trees per face. Trees per face. Tree. Lighting. Yeah, what's up, Ford? Hello, hello, hello. What's up, what's up, what's up? That's pretty epic. That's pretty epic that you're here. I'm really glad to see. Like shading or shadows? I think shading. Yeah. So we're gonna do shading. But shadows sounds like also an interesting topic, but it's kind of outside of the project that we're doing. The probability of trolling depends on the amount of trolling you have done before, since you get Bendix. Oh, I see. Oh, Markovian. Oh, it's from Markov. Okay, Markovian process. I see. So I suppose the Markovian process is the process that is that could be modeled by Markov chain. I see. All right, that makes sense. Oh, cool. Fong, I think it's gonna be Fong, but I'm not really good at names of the lighting techniques. Fong shading, let me see. So is it based on the normals and the angle between the light source and normal? If it is, that means yes, we're doing Fong. Yeah, okay, so that means we're doing that. Because the only thing about the lighting is this explanation that you have a normal and you calculate the angle between normal and the light source, but I didn't know that it has a very specific name. So yeah. So flat shading and smooth shading. I suppose the flat versus smooth just depends on whether you interpolate the normals or not. I think by default we're going to be interpolating them because we're going to be passing them to from a vertex shader to the fragment shader, and I think that automatically interpolates everything. Flat shading looks cooler though. Yes, it does. It kind of looks old school. I really like this old school look of the flat shading and shit. I think it's pretty pogue. A pogue. I thought Fong shading was done per pixel. Yes, So what? I don't see any problems. So here's the thing, you pass a normal to a vertex or to a surface to the vertex shader. Then when the vertex shader passes that normal to the fragment shader, it will get interpolated, and essentially you're gonna have a normal per fragment or per pixel. So it's gonna end up being per pixel anyway, just because of the specifics of how shaders work. If you know what I mean. What is just... People, come on. This is a serious stream about serious topics, okay? Yuri. It's a Russian name, by the way. There is such Russian name, Yuri. Yes. Do we have any Yuris in the... Yeah, Yuri Gagarin, by the way. Ooh, I love it. Anyways, let's continue. Yuri is also serious stuff, I see. What about ray tracing shading? What about it? Why do you ask? What about it? I think KGB is watching right now. Well, I don't think I know, because I watch my VODs after the stream every day. So yes, KGB is in fact watching. Don't worry about it. KGB is watching Yuri. Yes. So what is the queue? So this one is gonna be called Vert. Watching other streams when you can just be watching your own. Yes. Okay, so let's rename this to Vert. Vert. Q. So T is, yeah, so it's just a triangle, so the current triangle plus the current vertex. But is it really the current triangle plus the current vertex? Oh yeah, it is. It is. I'm just being the debugger. I'm just being the debugger. What about RGB people? What about them? Okay, cool. So now we get rid of the IG and stuff like that. Maybe we're gonna just rename this to an index of some sort. So I would kind of call it like a strip index, right? Because it generates the strip triangle, if you know what I mean. So it's gonna be strip index. So we have a little bit more names here now, which is pretty nice, I think. Which is pretty nice. Pretty nice. Pretty nice. Chat is very excited because we're talking about Yuri, of course. Yuri Gagarin. Everyone is excited about Yuri Gagarin. You know, space and stuff. So yeah, if you think about it, Soviet Union first sent Yuri to the space. Yes, that's the biggest achievement. Yeah, we have Yuri. Yes, that's the biggest achievement of humanity is when Soviet Union sent Yuri to the space. Anyways, I think I want to make a cup of tea. I think I want to make a cup of tea. I think the Soviets were the first to get pictures from the surface of Uranus. Oh, not Uranus, Venus. Okay, I see. Like Pepperheads, exactly. So here's the tree. This stream got derailed so goddamn fucking hard. Holy shit. I love it. Strip index. Tree. Vert. Trivert. So this one is a try. I think it has to be called try. And this one has to be called vert. And this is gonna be a strip index. Boom. Cool. Very epic. Very epic. Nice, 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 nice. Bruh. Cool. Thank you for the hard work, moderator. You're welcome. I'm working really, really hard. Holy shit, I'm working so hard. I'm so hard right now. Let's make a cup of tea. Let's make a cup of tea. Does anyone have any questions while I'm making a cup of tea? I'm already streaming for an hour. And nothing has been done so far. This is horrible. And all we do, we talk about Yuri. Which is okay, I guess. Stalingrad. Is it green tea or some other nonsense? Nice way to start conversation with the person making tea. Imagine, you wanna start a conversation with the person who's making tea and you start with that line. Is that a green tea or some other nonsense? Hello, E2 Dara 22. Hello, hello. Clearly an English that thinks that English breakfast is the only correct choice. I don't know how to do British accent, I'm sorry. Do I have a British English breakfast? I don't think it's a British accent. That? Anyways. What tea do you drink in Siberia? Snow tea. What else do you think people drink in Siberia? There's nothing but snow in Siberia. We eat snow, we drink snow, we poop snow. That's right. Tomorrow I will not be Yuris anymore. No Yuris? Why? I mean, your name is fine. Your name is fine. There's some people who are called, you know, Simon, and they very naively transliterate their name to guess what? and they go like that online and thinking, why the fuck everyone laugh at them? So we do have like this name in Russian language, and people very naively transliterate it like that. This is a very common mistakes, and you didn't do that. So the best way you can transliterate it is maybe like this. That's the best way to transliterate it. Yes, yes. It's a way better way to do that. So yeah. But maybe, I mean, I'm not telling you how to translate your name. Maybe you're okay with that transliteration. Who knows? I don't judge. Anyways, I wanna kinda get rid of this function. Hello, bit stream 69. Richard equals Dick. Yes, as far as I know, this is how you shorten that name in English. At least that's what I heard. I'm not an English speaker, so I don't know. Oh yeah, Chitarina highlights with the username. I think this is the latest commit in the master. I'm not sure if it was released yet. What I did, I just fetched right before the stream the latest commit, and I built it. And the reason why I did, by the way, is because my Chitarina didn't support regular expressions in the filters, so I had to actually update Chitarina. Because without regular expressions in filters, I couldn't set up the current dig filter, right? So there is a current dig filter, which allows me to not impose the size of the message limitation on people. So yeah, so I basically craft a specific regular expression that detects digs. You see? What filter now? No, it's gonna be my trade secret. So the specifics of the dig filter is gonna be a trade secret. So people who post digs cannot, you know, circumvent it or anything like that. So yeah. And I'm gonna constantly update that dig filter over time as people bypass it, of course. Anyways, I want to inline this shit. You can see that we have like a very similar loop in here to this one, and I think it would make sense to inline that loop. Let me see how we can do that. I'm pretty sure we can just try to do it like that. So mesh per vertex. And when I pass this entire thing, oh, I see. So this is a mesh count, which allows me to, I see. So we definitely need to inline this entire shit. We definitely need to inline it. So what is going on, by the way? What is going on? Is everything okay? Okay, so everything seems to be okay. Everything seems to be okie dokie karaoke. So I'm gonna be doing that. So I don't have to calculate strip index twice anymore. I only have to calculate it once. And in here, we're gonna be doing a count plus 3. Probably wrong layout. Oh, okay. So let's try to translate that and see if it's not in MongoDB. Alright, hopefully it's not. So, Arabic. Yeah? Oh, it just says cock. Nice! I love that. Look. It's a rooster in Arabic. Beautiful. This is how you spell it in Arabic. That's cool. And it's probably not, because it's actually pronounced like dick. It could be a transliteration, actually. It could be just a transliteration. But is it not? I'm not sure. It's kind of interesting. I know nothing about Arabic, but very fascinating. Yandex translator says it's a dick. No. This chat is so immature. Well, which is kind of strange because I marked this stream as a mature content. I don't know why the chat is so immature. There's clearly contradiction. Clearly a contradiction. I'm quite curious when this you mean the cock copy pastas thing? It's been around for ages. It's like a Twitch meme that's been around like for many years. Is that yeah, there's just people going around in Twitch posting the "Do you like what you see?" copy pasta. It's a quite famous copy pasta actually. So yeah, I would even say iconic one. But why? Because it's fun? I mean, it is fun. Seriously, it's just fun to do that, and see the streamer's reaction, right? Especially if they have chat on the screen, and basically displays automatically what you paste there, and you paste something like that. It's just reaction is actually quite funny. So I do understand why people do that. So it does make sense. I mean, sure. So we have 4 nested loops. 4 nested loops. You haven't seen that before? I think Jae-young doesn't watch anyone except me. Yeah. It's true, okay. But by the way, if you don't watch anyone on Twitch, how did you find my channel in the first place? That's a very interesting question. So... no idea. Yeah, it's very strange. Okay, so I now should be able to get rid of this function, and look at that, chat. Look at that. 4 nested loops. Horrible. I also use global variables, and I also use goto. Imagine I have 4 nested loops, global variables, and goto within a single project. Holy shit. At least that explains why I'm unemployed. At least that explains why I'm unemployed. Alrighty. So here's the vertex. We iterate the current vertex and then we add this thing in here. What? Best? This menu is too powerful, somebody stop. I don't know. Okay, it doesn't work properly, at least. Oh shit. I should have not done that. I can't believe you've done that. This one has to be like face pairs and whatnot. Okay, so let's actually take a look at the code that I just removed. Let's take a look at the code that I just removed. So we're passing... yeah, so this one... yeah, A, B, C, D, and there we go. Okay, cool. So we need to just assign this kind of stuff in there. We just have to assign it. It's gonna be hard. It's gonna be hard. This kind of shit. What? What are you talking about? I don't understand. Sorry. So here is the size TA, then size TB. Right, size TB. so this is size TC. My neighbors are cooking something very, oh my god. So CV paste, and J is a pair comps. That means it's a pair comp index. There we go. And this is a size TD. Stop spoiling the story, Tsoding. I want to see it gets hard for myself. What? Sorry, don't understand what you're talking about. Sorry. So here's A, B, C, D. So and we have a strip index. And this one is a face pair index, of course. We have to also do that. Face pair index. And this one is more of a like X, Y, Z, W. So does anyone know what I'm doing right now? Does anyone know what I'm doing right now? Can anyone tell me what I'm doing? Because I forgot. I'm generating normals, right? I'm generating normals. So essentially, what we're doing, we're trying to generate a mesh of a cube from scratch. My neighbors love to burn the shit out of their pancakes. I feel the pain. No, my neighbors actually cook quite well, so they don't usually burn anything, but it just smells too fucking tasty. All right, so first thing we're generating a mesh of a cube. Right, so let me actually try to do something like that. So here's the mesh, mesh of a cube. So first we're generating the vertices of the positions and stuff like that. So, and this is what these 4 nested loops do. This is what they do. Just knock on the door and ask for some food. No, I'm on a strict diet, I'm sorry. Okay, so they're trying to generate, first of all, the mesh with triangles and shit. Right, so this one. Right, and then we're trying to generate colors for each individual vertex in here. So each face of the cube will have its own color just for the debug purposes. And we're also generating UV coordinates so we can map a texture. Right, and so this is what this 4-dimensional loop does. It generates all of that data from scratch procedurally. Right, so we don't have it baked anywhere or anything like that. It's just, generated procedurally from scratch. That's why it's so complex, right? Because we're generating it from scratch. And what I'm trying to generate right now, I'm trying to add a generation of normals, right? So, and normals for each individual like face are going to describe how to treat the lighting, if you know what I mean. So we're going to have this thing here. Then we're gonna have this thing here, and this, and then this, and then this, and so on and so forth. For each individual face, yeah, we're gonna have this kind of stuff. Right, and once we've done all of that, we're gonna pass all of that information to the shaders, and we're gonna use that information in the shaders for the lighting. So, yep. So I'm trying to add this kind of generation. But instead we keep talking about yours. The only way for smell to go away is to start chain smoking. Well, another way is COVID. I'm pretty sure COVID is more reliable way to get rid of smell. Does each triangle have a normal, or do all vertices have normals? Right now, nothing has normals at all. Nothing has normals at all because I haven't implemented that yet. I'm in the middle of implementing, where I'm talking about non-existing code. The code does not exist. The code I'm talking about does not exist yet. So what I'm trying to do is see what's going to be the easiest way to generate normals that I can use for lighting. And this, so far, looks like the easiest way to extend my current code. Does it make sense? Both at the same time, yeah. It's actually quite amazing how reliably COVID destroys your sense of smelling. It's like you never had it before. It's like completely fucking gone. It's fucking amazing. I mean, it's not great, but I mean, it's just like, holy shit, it's just like very surprising. Sense of taste too. No, it depends on what you mean by sense of taste. Because there's such thing as flavor, right? So what's the difference between taste and flavor? So you have your taste buds, right? And they allow you to taste 5 specific tastes, right? So they're salty, sour, bitter, sweet, and umami, right? So you have taste buds for these specific 5 tastes. But by themselves, these tastes are pretty bland. What you need on top of that is smelling. So basically, the flavor of the food that you eat is a combination of the taste that you taste with your taste buds and the smell that you sense through your nose, but from the mouth. So it's basically combined experience. What the COVID essentially does, it gets rid of your smelling, so you cannot experience the flavor in its full potential because you don't smell anything, but you still can taste salt, sweet, sour, bitter, and umami as well. And I actually tasted that because I could still taste something when I was eating, for example, chicken, because chicken contains amino acids that stimulate the umami buds. So it was actually kind of interesting. So I didn't have any smelling. Majority of the food tasted bland, but if I ate chicken, I could still sense something. I could still sense something that I could point out, and I suppose that was the umami. So yeah, that's my I'm just sharing my experience. I don't know. I could be wrong on everything I said, but this is my understanding of how the taste and flavor and smelling works generally. You can of course verify all of that on the internet by just googling how all of that works. Thank you for a TED talk. Yeah, probably. Just a second. Alrighty. So yeah, this is what we're doing. We're trying to generate the normals. So I'm trying to simplify the code by getting rid of some unnecessary functions. So here we're generating the mesh, here we're generating the colors, and then here we're generating UVs, right? So I can even split all of that like this. Mesh, color. Hope for your speedy recovery. I recovered from COVID a long time ago, actually. I don't know what you're talking about, but thank you. UVs. All right. So that should be all right, I think. I think that's pretty much it. So maybe I can actually replace this kind of stuff directly. For example, we don't need DV in here. I can just say 1F. And CV paste could be also like this. So that simplifies that even further. I could probably try to inline this stuff. CV paste. CV paste. Oh, by the way, Borini, could you try to post a Hydra yet again? I promise I'm not gonna ban you. I just want to test the latest cock filter. I'm not gonna ban you. I just want to see what's gonna happen. But if you don't want to, you don't have to. I'm just, you know, just want to test how things work. All right. But keep in mind that they're going to be timed out for 13 seconds, I think. I'm scared. No, don't pause then. Sure. I mean, it's understandable. You have a PTSD from my latest interaction, so that's okay. I do understand. To be fair, I was a little bit tilted yesterday. Perfect. It works perfectly. Thank you so much. Thank you. So, yeah. So it's going to be like a 30 seconds timeout, and after 30 seconds, it's going to be all right. Yep. And it didn't display here. So, yeah. So essentially, this is how it works now. If you post this kind of like ASCII art, it's not going to be visible just on the stream. Yeah. Should be all right. Thank you so much. Thank you. Yes. But through the bot, it works. Yeah, but I get time out by the bot anyway. Yeah. And aren't deleted messages gone? Could rely on that, but the bot might not be always online all the time. And on top of that, I want to see deleted messages as well. I want to see the deleted messages because people might be saying something important and it could be false positive on links and stuff like that. So yeah. So for example, I still want to see these messages, right? But yeah, I don't want to show the cocks on the stream. Yeah. So it's kind of a complicated situation, so you have to like it's trade-offs of different things that you have to constantly decide on. Yeah, but if you do that not through the bot, it's not gonna work. So sorry, come back. So you guys slowly figuring out how the filter works, which I mean it doesn't do anything magical, so it's just like, you know. Alright, so let me try to do this thing. Kidita, and I didn't break anything, so the degeneration of the meshes still works. Yeah. Degeneration of the message of this thing still works. Degeneration. Consa figured it out, yes. Consa figured it out. Alrighty. Degeneration foundation. Yes. Ooh. Alright. So right now I'm kind of like okay with this kind of posting, right? So the headers get deleted, you know, by the bot. They're never shown on the stream. I still can read the deleted messages because they may contain something important. So overall, I think it's a pretty good trade-off. I found, right? So it's a pretty good trade-off. So yeah. It was kind of difficult to come up with this trade-off, but yeah, so it seems to be okay now. So yeah, so we're generating the mesh, and I wonder if it's gonna look too bad if I try to inline these things in here. As you can see, I could try to inline them. I think it's gonna be too complicated if I try to inline them, so I'm gonna just split the thing like that. And I would really recommend to use ASCII5 with the $sign. It's a little bit more powerful, to be fair. It's a little bit more powerful. Fuck. Okay, no. Have any experience in making a web front end in Rust? Is the rocket handlebars good? I mean, Sleep Lurker, please do not abuse that. I'm gonna time you out. Come on. 30 minutes. I mean, it's funny, haha, but, you know, come on. What? So what do I need to say? I don't know. I have only experience for front end, and you probably mean like WebAssembly, right? So I only program directly in WebAssembly, never used Rust. So here's the mesh, and we want to also generate here normals, right? So we're generating normals. How are we going to be generating normals? That's a good question. So normals is going to be count plus 3. So this is the current vertex, right? This is the current vertex. And within that vertex, right, we're going to be generating different stuff in here. Just basic generated HTML for database tables, and I don't want to learn JS for that. JS is actually quite simple. Probably depends on what exactly you're doing, but JS is a pretty simple language. The problem with JS is that it's dynamically typed, so some things are kind of difficult in it because it's difficult to refactor and shit, but it's pretty straightforward. Because, like, in my experience, with all of these modern technologies that compile this, you know, older languages or native languages to web, like, the amount of effort you're gonna put into, like, making something work is not comparable with the amount of effort you're gonna put in for learning JS and writing application in pure JS. Seriously. So the amount of effort to make Rust or C++ compile for the web and the amount of effort just write it directly in JS, it's really disproportional. The amount of effort you have to spend troubleshooting shit with the Rust and C++ is just like, it's just not worth it. At least in my experience. Maybe you're gonna have a different experience, but for me it's just not worth it. Because they all have very complicated tools, like it's just like all of these layers upon layers of lasagna of abstractions, generators upon generators. All of these pieces may not work together. Like why? It's just easier to write directly in JS, and JS is essentially just like a normal language. Like it has functions, it has procedures, right? Ifs, for loops, variables. Now it has classes. So it's like your normal language that you probably already program in. It's just like has all of these constructions, and so in terms of like maintainability, it doesn't require too much. Right. All right. Well, maybe TypeScript may make it a little bit easier for you to work with, but I don't know. So here are the normals. And we're generating x, y, z, right? So x, y, z. So in here, I might as well try to just take. So speaking of D is also like W, right? Is it not? I'm pretty sure D is also W, so I can always just say W, right? So this is gonna be that. So D is not needed anymore, which makes it a little bit easier for me to do that. All right. And maybe I'm gonna just get rid of this thing then. So mesh generation. Oh shit, it didn't recompile properly. All right. Does it recompile? It still recompiles. I didn't break anything. Nice. We can try to break something. For example, if I don't generate UVs, what's gonna happen? And very interesting. That's a very interesting color for the cube, to be fair. But anyway, so I mean that everything works as expected. Yeah. Copy. Where is my images? Baited PNG. Cool. So. The background really weird. Huh. That's very interesting. That's a very interesting background they got there. Is it really there? No, it's not there. It's probably something within alpha, like within the background. I think the background just, they set alpha to 0, but we don't take alpha into account, and that's why now the background is visible, because background looks like, you know, something is there, right? So the actual background from the photo, right? So that's very interesting. That's actually very interesting. Emacs can show images, yes. Surprising. Surprise, surprise, Emacs can show images. It cannot do a lot of things. Unfortunately, it cannot zoom them in. I try to zoom them in, it just doesn't allow me to do that, unfortunately. So yeah. System E. Is that a forcing related thing? A lightweight system D replacement written in Emacs. God damn it, I was hoping that it's a forcing reference, but okay. I can zoom with, oh, maybe you have to compile Emacs with something to enable that, but it just doesn't work for me. Wait a second, I don't really press plus. Oh, okay, I see. I see. Alright. 2256? Is that a new record? Is that a new record? Emacs Magic. Back to fridge, nice. When did it happen? Yesterday, nice. Perfect. Back to the fridge. The neat manager for scenarios. Images. We get PNG. Okay. Did I close it? God damn it! I fucking closed the application. Yeah. Are you a member of any demoscene group, dude? Or I don't know. Don't want to assume a gender. I just learned how to render a cube 4 days ago. 4 days ago. Is that how I pronounce it? Probably. So yes, I am a part. I'm an epic demoscener. I'm an epic demoscener. Yes. Like 4 days ago, I didn't know how to do this shit. So. All right. Let me see. Well, so let's actually generate normals. Let's generate normals. Okay, so here's this stuff, and everything seems to be working correctly. Everything seems to be working correctly. I should stop stalling and, you know, start working. So here's the normal, here's the vertex, and in this particular case, A and B show what things you have to set up as empty. So we can actually move these things out there, right? So, and all of these things could be, by the way, const. And C indicates the one that you have to set to -1 or 1. Today I made my first API call in Rust. What do you mean by API call? So REST API call or API like to C? Because API can mean a lot of different things. I'm not quite sure. Quite sure what you mean by that. So it's going to be A, B, and C. All right. But in any case, congratulations. Congratulations. That's very cool. So A and B has to be set to, I suppose, 0, right? These are normals. And I would assume that normals are just vectors. They're like relative to the vertex they're in, so I can just safely set both of these things to 0. Right, and also it depends on what face we're currently drawing. So if I draw in the first face, it points that, right? So that means it has to be negative. So depending on the current pair comp index, right, pair comp index. If pair comp index is 0, we have to put -1. If it's 1, we have to just put 1. Yes. And W is going to be just 1, regardless of anything. Regardless of anything. So this was actually a pretty cool idea to give these indices proper names, because now it's actually a little bit easier for me to navigate in this generation thingy. It's actually way easier to navigate. So this is a static const. I wonder if I can make it super const, very const, or something like that. Whatever, we cannot. Which lighting model is the forward or deferred? I don't know what that means. It's a POG lighting model. Yeah, it's a POG lighting model. So if something, how can I map 0 to -1 and 1 to just 1? Right, essentially, if I have, so this is the index. If it's 0, this could be just -1 multiple, yeah. If I is 0, is going to be 1, multiplied by 2, I think. There we go. So this is how it could be. So if I is 0, this is going to be -1. If I is 1, it's going to become 1. So this is how you map 0, 1 to -1, 1. Yeah, essentially. Yeah, I guess. So, and in our case, I is a pair component index, right? It's a pair component index, but yeah, it has to be converted into integer because it's size t. So, and after that, this entire thing has to be converted to float. Right? It has to be converted to float, and there we go. So this is how we achieve the epic victory royale. Yes, I suppose. So that's how we generate normals, and I think we did in fact generated normals. Trees per phase. So here is that. So we can actually, yeah. Let me see. Didn't break. Let's move this thing in here and do just +1. Right, so here is the first, and count is the amount of, like, yeah, I guess the amount of triangles that we generated. It's the amount of triangles that we generated. And yeah, so this assertion is actually quite important to make sure that I didn't do any major fucky-wacky. Yep, I did in fact make a major fucky-wacky. Interesting, so that didn't really work well. Oh yeah, I know why. Because if I'm gonna move in it there, I have to get rid of the +3 for each of these things. But before I can do that, I need to do a committee and maybe even pushy. All right, so let's go. So I have a cube object. So let's do this thing like that. So I deleted everything. Use IAF for the cube. Just a second. Refactor mesh generation. Refactor mesh generation. Let's push that right into the repo. So let's use it. Sure, I'm okay with that. Yeah, PNG. There we go. Weebs. Dance game. Weebs out. Weebs out. Alright. So let me see what we have. Let me see what we have. Cute cube. Yes. So here are the normals, and yeah, what I wanted to do now, right? So this is that. Trees per face is going to be just +1, right? Just +1. But we also want to get rid of the +3. So query replace 0 + 3 with nothing. This. Boom, 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 boom. There we go. So that simplified things a little bit, just a little bit, just a little bit. Yeah. Okay, it worked. So that's pretty cool. That's pretty cool. That's pretty cool. I can see everything. I see absolutely everything. Okay. So yeah, so now this is how the mesh generation code looks like. I think it's quite readable. We're iterating each face pair of the cube. Then within each face pair, we iterate each face of the pair. Within the pair, we iterate through each triangle of the pair. And within each triangle, we iterate each vertex. And as we iterate each vertex, we generate more and more information for the mesh, the colors, UVs, and normals. Does it make sense? Right? So we iterate pairs of the faces, each face within the pair, each triangle within the face, and each vertex within the triangle. So that's why we have 4 nested loops, because we need to iterate things like that. I think it does make sense. Yeah, we're not doing triangular strips. Maybe with triangular strips it would be a little bit easier. But with this stuff, it's kind of, it's also okay, I suppose. It lets us generate a lot of interesting things, like mesh, color, UV, normals, and stuff like that. What do you guys think about this kind of generation? I think it works. I think it works well. So we can try to dump the normals that we just generated, just to see what's gonna happen there. So we generated cube mesh. And then I'm gonna iterate through all of the triangles in the cube. Generation over. Yes, it's very catchy. I know. That's the reason why I keep saying that, because it's very catchy. Trees per cube. Degeneration of our nation. Okay. So this one is gonna be vertex, tree vertices. Yeah, proper names do help to keep track of all of these things, which is super nice. Super nice. N, and it's gonna be v4arg, normals, I'm sorry, vert, should be okay. Maybe time to write some sort of macro for this nested loop. Maybe. I don't know. I don't really use that very often. And I don't really want to hide too much information about what's going on. I think it's alright. At least for now. So we don't need this thing, by the way, anymore. So this is a cube mesh. So does it compile? Okay, let's take a look. So here are the UVs that we generated. And yep, I can already see a Fakiwaki. because I forgot to use ABC. Yes, I'm supposed to be using ABC. Right, and ABC is just like the switch between different planes and different things. Yeah, fucky wacky and oopsie doopsie. That's exactly what I just did. Fucky wacky and oopsie doopsie. Here are the normals. So for the first phase, the normal is just x and y are zeros, but the z is outwards, which is negative. For the next one, z is positive. Then for the yz, so it's gonna be yz, x is going to be negative, and then it's going to be positive, and just we iterate through all these things. And I think these are kind of okay normals. Do you recommend OpenGL for someone who's just getting into C game programming? The problem is that I'm not the right person to ask this kind of question, because I'm not a game developer at all. Like, I've never done any game development in my entire life, especially commercially, right? Well, I mean, I've done game development, but I never done it commercially. I'm not a part of the game development industry. I've never worked in game development industry. I'm not a game developer, so I don't know. The second thing, I know nothing about OpenGL. Seriously, like I just copy-paste OpenGL snippets from the internet, just put them together and they kind of work. And the second thing, I know nothing about C. The same as with OpenGL, I'm a more of a professional Java developer, so I'm not qualified to answer your question. I have no idea. So you probably have to ask somebody who's like a professional game developer. Like, go ask John Blow. He's like a professional game developer. He's been developing games for his entire life. He probably can answer your question. I just copy paste code from the internet. I know nothing about this shit. Sorry. So yeah, does it make sense? Okay, so we implemented this shit. Cool. We are generating colors, UVs, normals, and everything looks okay. Okay, guy. Okay, guy. All right. So what did I do exactly here? LWGGL. LWGG. I don't fucking know how to pronounce that. That's a very good name for the library. It's a beautiful name for the library. Holy shit. It's so good. Anyways, so we generate the normals, right? The time has come to pass those normals to the shader. Let's pass it to the shader. Ooh. So we're gonna pass it to the vertex shader, right? So it's gonna be located somewhere in the location 2, right? And it's gonna be vec4 vertex normal. So this is what we're gonna do here. Vertex normal. Cool. So let's go. Ooh, let's go. So what I'm thinking is that we can even test those normals, because we can add them to the position, to each individual position, making the cube detaching faces from each other. Yes, this is how we can test if we didn't do any major fucky-wacky. Yesu, kawaii desu, holy shit. Alright, so it's gonna be query replace UV normal. Boom, boom, boom. So then we're gonna have V4. Do we have anything else? I think that's alright. That's alright. Alright. So, but this has to be 2. Okay, are you guys ready? Are you guys ready? Bam! Okay, you cannot see shit in this mist yet, but we are about to do something cool. Right, so I might as well actually make slightly smaller. Let's try, we know the normal, right? We know the vertex normal. Let's try to detach the faces of the cube from each other a little bit, right? Let's try to detach them a little bit. So how are we going to do that? So we are starting with vertex position. I wonder if I can set vertex position somehow. Let me see. So vertex position is going to be equal vertex position plus vertex normal. And since we are in like a very big space coordinates, I wonder if it's gonna do anything. Okay, so it didn't work, probably because failed to compile assignment to read only. Okay, I do understand that. So let's actually call it slightly differently. Let's define some sort of a variable. Vec4 vec4 position. So, and it's gonna be simply vertex position, and everywhere we're using vertex position, we're going to be using just the position. There we go. Is it going to compile? Yes, it is compiling, but now everything is completely detached, as you can see. It's actually more detached than I expected. It's more detached than I expected. I wonder why. Probably because we do that after after we applied everything there. So we'll probably have to do that. So here's the GL position. So we need to have a camera position, something like that. We can always do something like this. We can multiply it by half, of course, and just make it slightly smaller. 25. Okay, so something went horribly wrong. Oh, I stopped it. I see. Holy shit. That's probably why. We need some sort of an indication that I'm in a stopped mode. But yeah, so this is essentially what I'm doing. Right. So knowing the normals of the faces allows us to detach them from the cube, right? Because they're facing away from the cube. They're facing away from the cube, and we can use them to adjust the positions and see if we generated them correctly. Furthermore, we can even we can even animate the shit. So that's very interesting. So since we cannot print f the values, right, we can just use our values in the animation. We can use them in animation to just confirm our hypothesis whether we generated correct data. So as far as I can understand, this is how we debug things in computer graphics. Right, and as far as you can see, the vector normals are generated more or less correctly, I suppose. All right. So you know what I want to do? I want to make a small break because I need to pee. So how many minutes? I think 3 minutes should be all right. All right. Let's make a small break, and you guys have fun. Hey yo, what's up? How's it going? Epic cockers? Okay. So this shit is kind of strange. So I would like to modify the animation slightly. Okay, so this is the current animation. Basically, I don't want it to be so off-centered, right? It's, as you can see, it's so off-centered, and also the faces go through each other. We don't want to do that, right? It's kind of weird. So let me see what we can do about that. Maybe I'm gonna actually just do it like this. So this is gonna be vert, and yep. So you know what? Hyper yup, maybe. I'm gonna just title the stream as yup. So we're not gonna try to modify position like this right now. Right, we're not gonna try to modify it like that. So let's put it here. So this is gonna be vertex position. Right. So this is a classical vertex position. So now they do not, you know, detach or anything like that. They do not detach. So what I want to do here, I want to extract this value into a separate thing, and we can call it something like a camera position, right? So it's going to be vec for camera position, right? So this is the camera position, and it's essentially this, right? It's essentially this. It's a camera position. We use the camera metrics, and then we define position, and we can actually put this thing here. So camera pose. This is the camera pose, and the vertex is the camera pose. Camera position. So that didn't break anything. That didn't break anything. Yep. So there's a pretty cool emote on BTTV called Yeppers, I think. Let me Google it off screen, because you never know what Google's gonna show. I really like that. Really like that emote. But BTTV is like a third-party thing, and I don't know. No, it's not that one. There was like a better one. Too many doc memes, probably. Too many. I should restrain myself. Anyway, I couldn't find it. So let's continue. Alright, so we have a camera position, and maybe we actually want to like take each individual thing. So I fix it up here, I rotate it accordingly, and then I scale it. I think I'm gonna actually rotate it after I scaled it. So I think it's going to be easier for me to work with all of that. And afterwards, this one probably, as you probably found the same one I found. Yeah, that one. Yeah, I really like this one for some reason. Thank you so much. Should we edit? I want to edit. Yeah, there we go. Yeppers. Yep. Okay. So we translate scale, and afterwards I want to translate each of them according to their normal. Yeah. So essentially it's going to be mat for normal. Actually, translate. Right. Translate, and the normal is going to be, yeah, we're going to just do normal XYZ. This is how we're going to be translating it. And it's really? It's normal. Still doesn't work. Okay, so what's the problem? Camera Wait, we don't have a... It's a vertex normal. Okay, vertex normal. Okay. Okay, so it's supposed to actually slightly detach it or something like that. Союз нерушимый республик свободных. I'm sorry. So here's a vertex, and I kind of want to multiply this entire stuff by, let's say, 5 or 6, whatever. I already typed 6. So that detaches this stuff slightly, right? So it's going to be like 10, and yeah, that actually looks okay. And I think if we change the texture, right, it's going to be even more visible. So now we have this kind of stuff. This is what I was looking for. This is what I was looking for. Old habits die hard, exactly, yeah, sure. Okay. I'm just an old Soviet software development. I lost my job when the Soviet Union dissolved. And now I'm forced to beg for money on the internet. So please subscribe or donate, and in exchange of small donations I will show you funny pictures. Yes. So, cheers. So Ramon, don't be sad. Everything's gonna be okay. Dissolved in what? In vodka. Vodka is pretty good solvent. Anyways, so what I want to do actually, I want to kind of animate that, right? So this is going to be, let's say 20. So this is how much they're gonna detach from each other. And now I want to multiply this entire stuff by sine of time, but sine of time goes from -1 to 1, and this is why they keep intersecting with each other. So what we want to do actually, we want to add 1, right? So we're going to add 1, but the problem is that now it's going to isolate from 0 to 2, which is not particularly great. So to fix that, we need to divide it by 2, right? So we're going to divide it by 2, and now if I do this, it does that, and then yeah, that's actually pretty cool. Look at that. That's pretty epic. So yeah, normals do work correctly so far. Pretty cool. Rotation chamber, yeah. Pogue. So now I want to actually pass normals to the fragment shader, right? So we're going to try to pass normals to the fragment shader. So it's going to be out vec4, vec4. What's interesting is that normals contribute to the, I think, oh, they are not contributing to the W coordinate because we specifically take XYZ, right? So we specifically take XYZ and we ignore the W coordinate. I'm guessing this. Okay, I'm gonna stop it. Normal. Okay, so we're gonna pass the normal to the fragment shader. Let's actually wait until. Yeah, so this is where we're gonna stop all that shit. Okay, so where is the fragment shader? In the fragment shader, we're gonna accept the normal. We're gonna accept the normal, and this is where we can do things, I suppose. This is where we can do all of our calculations. So let me see. So I just reloaded the shaders, everything seems to be okay, but we don't really set the normals yet. So this is a vertex normal, and here I'm gonna set normal, vertex normal, right, vertex normal. There we go. So nothing broke, everything looks okay so far, so the memory usage is okay. That's a pretty big texture, right? It's a pretty big texture. All right, so I'm gonna go to the fragment, and in the fragment, we also want to know the position of the light. All right, so we need to know the position of the light. So we're gonna probably just assume it to be somewhere. Big textures, big cloth. Yes. So maybe so far, I'm gonna just remove this translation. Yeah, it's gonna be like this. Main frag. So where are we gonna put the light source? Where are we gonna put the light source? So we know the, yeah. Oh, by the way, the light source, the position of this thing is constantly changing, right? The position of this thing is constantly changing. Oh shit! We do need to apply all of the like transformations. All of the camera transformations to the models as well. To the models as well. To the normals as well. But except the position. At least we need to apply the rotations and whatnot. The rotations have to, yeah. Oh my god. I want to make a cup of tea. So, does anyone have any questions while I'm making a cup of tea? Because we're gonna dive into pretty hardcore stuff. Not really hardcore, but I'm doing this kind of stuff for the first time, so it's kind of difficult for me. Yeah, because you need to keep track, like keep mental track of a lot of things. So, does anyone have any questions right now? Can I have a cup of tea too? Sure. You have my permission to have a cup of tea. Hardcore OpenGL. Yeah. Because for lighting to work properly, the normals should rotate along with everything else. Right, they should rotate, but they shouldn't really change their positions or anything like that. So their positions don't matter that much. So, and also scaling might not really matter that much as well, right? You just put them apart. But here's yeah. For transforming normals, you need to transpose of inverse of the regular model matrix. I don't understand this terminology. Model, view, controller, whatever. Like, I don't understand like the differences between them. For me, like I think in terms of, you know, the point and how I scaled and translate the point to put it into the cube -1, -1, -1, -1, -1. I don't understand this MVC shit. So, all right. Does anyone have any other questions? I have a question, but not really about your project. That means I'm not really interested in it. There's a limited amount of texture units in OpenGL. Yes, I heard about that. Should I make large sprite sheets or keep swapping the textures in the middle of drawing a frame? How do big games solve this? I have no idea. I'm not a game developer. I'm learning OpenGL for the 4th day, pretty much. So I know nothing. So sorry, I'm not the right person to ask these kind of questions. Why people think that I'm a game developer? Like the only thing I can do is just a rotating cube. Like, how does it make me a game developer? Okay. Yeah, ask John Blow. If you have any questions about game development, just ask established game developers like John Blow. Just wait until he's streaming and just ask your questions to him. All right, so I'm gonna go to the kitchen, turn on the kettle, and I'm gonna be back. What's up, Epic Game Developers? How's it going? How's it going? How's it going? Now. So what do we need to do? So we're translating everything. We don't need to translate normals. We're trying to scale something. We don't have to scale that. Do we need to rotate shite? I think maybe. It feels like we only need to rotate normals, if you know what I mean. We only need to rotate them. Because anything else just doesn't really matter that much. To be fair, we also keep track of the current vertices. That's what's cool about it. We keep track of the current vertices in the fragment shader. So you have a vertex, right? And you have a normal, right? So yeah, that means it's, yeah, you only have to like rotate it and shit. Okay. So I'm gonna just take this, and when I'm applying the normal, I'm gonna just do it like that. So it's gonna be like this. Hopefully I'm violating all of the MVC principles in my shaders. Alright, my tea is ready. So is the cube moving or is the camera is moving? How do you know? How do you know? What's the point? If you don't have a point of reference, like a frame of reference, how do you know? Depends on the frame. Exactly. Illich understands. Yes, yes, exactly. Depends on the frame of reference. So what's your frame of reference? So here's the normal and shit. Okay, so let's put it this way. Let's put it this way. So vec 3 light source. So here's gonna be light source. We have, let's actually put the light source somewhere at 0, 0. But in terms of the Z is gonna be somewhere in the middle. So it could be actually somewhere in front, maybe even. It would be also kind of cool if it was on on the side slightly. Let's put it a little bit closer, like a little bit to us. So it's going to be somewhere in the middle of the way from us to the farthest away point for the cube. Right, and let's put it to the side slightly. So in terms of x, it's going to be something like 10. Yeah, so this is around where the light source is going to go. So next. So we have the light source somewhere here. And we need to know the position. We do have the position because it's the vertex. Right, we do need to know the position. Okay, so that means we take light source minus the vertex, because we already pass the vertex for the fog. Right, we already passed the vertex for the fog. So that gives us the vector, right? So this is the first vector, and the second vector is the normal. So we need to find the angle between the vectors. We probably can do a dot product between the vectors, and that kind of gives us the angle, but I don't remember how exactly it works. Okay. So we'll probably have to do, okay, angle between vectors in 3D. Here comes backseaters. Here come backseaters. They're gonna hit me with a huge wall of messages telling me to read something or trying to explain something. What the fuck is this website? This website is horrible. This is so goddamn fucking horrible. Okay, so below given... Alright, so essentially of the dot product, so the dot... okay, that makes sense. Dot product is gonna give us that. And maybe we can just use the dot product directly. Or maybe I just need to... yeah. I kind of want to first try to do everything myself. Yeah, there you go. Here's all of the backseaters. Yeah, should have actually left the filter. So maybe I'm gonna just go ahead and read it, because I'm obviously gonna waste time if I'm gonna try to do it myself. So, by the way, dot product. Remember dot product represents sort of like an angle, but not really. We can try to use the dot product. Okay, so GLSL dot product. GLSL dot product. So it's OpenGL 4. The first two vectors x, the second of two vectors. Okay. Second of two vectors. Yeah, geometrical definition. I know. I need an yeah. So there was a pretty cool animation with this kind of thing. Okay, so let's do that. So let's find the dot between them. So it's going to be dot, something like this, and let's put it to A. So this is what we're gonna have. This is what we're gonna have, and depending on that value A, so what we can do there? We can try to, you know what? Let's actually set it to a very specific color. So the cube is gonna be something like a reddish now. Right, so it's gonna be 0, 5, 0, 0, 0, 0, 1, 0. And I might as well actually put it like this. Right, just put it like this. Rect color, vec4, 1 on behalf. Yeah, it might not have this thing, but we'll see. Yeah. No matching function error. Huh. Light source vertex is 4-dimensional. Okay. Okay, so it still doesn't compile. No matching function vector 3. XYZ. Let's try XYZ then. So here's the red thing. Here's red. Looks pretty cool. Now I'm gonna try to use the A as the color. So, and does it change anything? Huh. That's very interesting. Doesn't really change that much. So we probably need an angle, like an actual angle. So cosine is gonna be that. Okay, so I probably don't understand. Okay. Fong lighting. Let's read about that. Fong shading. So how do you calculate? Interpolation. Okay, diffuse, ambient. Flat shading is a polygonous. Okay. Is there any article? Okay, GL OpenGL Fong shading example tutorials. Let's find them. Don't really want to make a complicated shit in here. I want something very simple. But they are trying to make it very complicated for the first example, because obviously this is like a gatekeeping situation. Alright, so how do you calculate? Okay, so here is the light source vertex you normalize. Max between dot and 0. This is very interesting. This is very interesting. So it's a they do the same thing, as you can see, right? So they subtract the light position from the vertex. Okay, that's exactly what we do. But on top of that, they normalize it, right? They do normalize it. So maybe that's exactly what we need to do here as well. So let's normalize it real quick. That's pretty cool. And I almost came up like with this thing myself, but I'm too stupid to realize how to work with that. Right, so then we try to do the dot product between normal and the light. Right, so this is our dot product between these two things. That's perfect. That's absolutely perfect. And then we're trying to find the maximum between them, right? So we're trying to find the maximum between 0 and this thing, in case this thing will become negative, I suppose. It's kind of strange, but okay. All right, so... Oh, shit! I fucking did it. Well, yeah, so maybe I have to move it slightly even more away from, like, from the X and stuff like that. Let's actually put it to 25. Well, yeah, so there's, like, in terms of this stuff, it just doesn't really work that well. Can we actually put it on the person? Yeah. Ah, shit. Well, I mean, yeah. Okay, so that's pretty pogue. That's actually pretty pogue. But we also need to do that with the texture. We also need to do that with the texture. Okay, so how are we gonna do that? So obviously this thing just goes from... Alright, so we're not gonna apply the fog for now. We're not gonna apply the fog. I guess we're gonna apply... So here's the texture color, and this is what we have. And I'm thinking, what's gonna be the best way to do that? So I wanna make it... The bigger it is, the brighter it should become. Can this thing multiply by A? But it also affects the Y, so... Well, we can try, maybe. Maybe we can try. It kind of works, sure. So, but we need to do that without the fog. We need to do that, try to do that without the fog. Like that, and yeah, so lighting works. But not when it's inside of this entire stuff. I wish it worked also from with... I think I know how we need to make it work. Instead of max, yeah, we need to do ABS. There we go. That will work inside. I think it... Yeah, it kind of works inside. But then, you see what I told you? It affects A. It affects A as well. So we probably have to do XYZ. Multiply vector for 1 or something, so that could probably do it. Yeah, so that's better, but the lighting actually works. The lighting actually works. That's pretty cool. I like that. So you can clearly see that, especially like here. And stuff like that. So we can also add the fog, right? So we're gonna have both. We can't have them because I made a fucky wacky. So here is the fog, and within this thing, so there's the lighting and there is a fog. But the lighting is kind of So you can see like a spot of the lighting. But apart from that. Yeah, that was interesting. I finally learned how to do that. What does it look like without the lighting? That's a good question. I think there is a difference. You can clearly see the difference. So let's see. So this is with lighting. This is with lighting. And then without lighting. I see the difference at least. Yeah, there's a minor difference. Maybe the lighting could be actually of a different color. So that could be a thing. So let's actually save the texture somewhere. So it's gonna be vec4 texture is gonna be just t. It's not 5, it's just like t. Right, it's gonna be like that. So this is t and t x y z. Okay, so let's actually take maybe xy. How can we actually add the light? Right, because we are just increasing the brightness, but we could be increasing the brightness of a very specific channel, right? For example, I'm changing the brightness of A specifically. It's almost like I could be mixing that value more. We can try to do the mix there, right? So this is going to be like that. So I'm going to be mixing the texture with color, let's say maybe red, with the red color, and the closer we are, the more light we have, the more we're mixing it with, which is kind of dumb, but yeah. I guess maybe multiplying. Yeah, we could actually try to multiply the colors by that value specifically. Oh yeah, that works. That actually works, believe it or not. So that creates this very interesting light, which could be different. Red room. So it's more of a yellowish now, and this is more of a whitish color. Yeah, I guess you can do that now. So this is gonna be like that. There was something, I think I saw something weird. Let's go back. Underwater. Yeah, you see there's some weird alpha shit going on. Yeah, you can see that there's something alpha-ish. It's not even really clipping, right? But in terms of alpha, there's something weird because of this thing, right? So we can try to do it like this. Okay, so yet again, this is going to be 3, right? And this one is going to be XYZ, and vec4 is going to be just always 1, right? And there we go, this thing is gone. Right, so now you cannot see that alpha stuff anymore. So that's very interesting. It's kind of hard to tell, like there's like more like darker spots in here, right? Darker spots. You know, the main difference why it doesn't really look that different is that because we don't apply maybe the distance, so maybe the distance of the light should be a little bit shorter or something. So light source. What if we have what if we cut A in half? Is it going to be more interesting? Yeah, it is more interesting. Yeah. Okay. So what about without the fog? I think without the fog, it's going to be very clear what we're doing. So this one is going to be always 0, right? This is always 0. And let's actually go here. And then I'm going to try to remove the lighting, right? So I'm going to try to remove the lighting. So this should be without the lighting. So this is without the lighting. With the lighting. I can even use the white color for the light, right? So this is with the lighting. This is without the lighting. There's a clear difference now. I think like a fog and lighting kind of mix everything up, but if you just compare them like that, there's a clear difference here, and it's actually, yeah, it does make sense. Inside of the room, it also does make sense, especially if we, you know, make it, you know, affect things slightly less. Right, so maybe even half. Can we put it in half? It just makes it darker, to be fair, but the differences are gonna be like this. Yeah, but inside of the room, it's not really that clearly visible. Oh yeah, I think we did it. We made it work. Okay, I'm gonna call it a success, I suppose, because yeah, we implemented like a simple lighting and fog and everything. So I'm gonna keep it here. So this is along with the fog. So there's a lighting, there's a fog, there's everything. And now I do know how all of that works. That's beautiful. That's absolutely beautiful. Okay. So this is the vertex. Do we have anything else? Everything looks okay. By the way, can I... So we also do some translation here. What if I keep this translation? Oh shit, I'm in the wrong place. I'm in the really wrong place. Yeah, this is cool. This is even cooler. So that's funny. Alright. So we're using both normals and stuff for calculating light and stuff. Maybe we should try different like models of light, because you see there's like diffused, not diffused, some bullshit like that and everything. But different sort of lights are like, they do make sense when you have more sophisticated surface, like Utah teapot. Maybe we should learn how to load Utah teapot into our engine, quote unquote, and just try different fogs and lighting and shit like that. What do you guys think? I think that's another thing we can try to do, because we still have some time until the end of the stream, and yeah, we definitely need to do something. Is there like OBG model for Utah teapot? Utah teapot or OBG? Nice. Graphics standard EDU. So this is the vertices, right? These are the vertices. What is F? What is F? I don't remember. Oh, okay. So these are like faces. Okay, these are faces. They are like indices, right? They're like indices. But why are they in... Okay, so I'll have to learn this format and understand why. Oh, okay, so they range from 1 to probably like 1,000. So there's like 1,000 faces in here. Which is fine, I guess. That makes sense. Which is fine. So we'll have to use the vertex array and stuff. Oh, I need to learn how to do that. So because there's like a vertex array object, right? And yeah, I never used it, but we'll see how it goes. So before I will start doing all of that. Holy shit. Tiny object loader. Seriously? Are you serious? Are you really serious? What the fuck is a tiny object loader? It's a goddamn text file. It's the simplest format you can come up with. Why the hell do you need a library for that? Like, you split everything by lines, and within each line you split everything by spaces. What happened to the developers? Like, why the fuck do you need a library for that? Like, do you need a library for everything? Like, do you need a library to sum up two numbers? Do you also need a library for that? Oh shit. Okay. Whew. I need the library to help me to be. Exactly. People. People. You forgot how to program. Do you need a library for for loops? Do you need a library to check whether an object is an array? Or wait. We already have that. Anyways, so we have that. Oh no, 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 no. Okay, so... Sodin lost a bit of his humanity when he saw that. What am I playing? Dark Souls? Losing humanity all the time? Yes. Anyways. Implement simple POG lighting. There we go. What the fuck just happened? Updates were rejected? What the fuck? Let me fetch the other stuff. What the hell is going on? Excuse me. Ah, okay. So today there were problems with authentication in GitHub. I got logged out from the GitHub, and that still kind of freaks me out. I'm still thinking that maybe somebody hacked me or something. I just merged out 9 pull requests. Everything's okay. So let's replace onto the origin master. All right, so everything's okay. Alrighty. Yeah, apparently everyone got logged out. So everyone got logged out. I got scared too. It's so goddamn fucking scary, right? Seriously. Because GitHub usually never logs you out. Discord does that from time to time, so you kind of got used to Discord logging you out, but GitHub? It just looks so weird. Alright, so let me see. By the way, you can find the source code of the thing we're doing here, right? So it's called Kidito for some reason. There's no particular reason. So yeah, two-factor authentication was POG. Two-factor authentication was a POG. Now, so this is a Utah teapot, and did they even leave this source? They probably didn't. All right, so let me go to models, right, and let's just do wget on this thing. All right, POG. And I'm also gonna put a comment in here, right, indicating that this is where we got it from, right? This is where we got it from, and it's like 10,000 lines of code. It's a 10,000 lines of code. We need to load this thing somehow. The file is actually relatively small. It's 200,000 kilobytes and stuff. Panapudi is here. Hello. How are you doing? Really glad to see you. How are you doing? We implemented simple POG lighting. You probably were here. You probably were watching. It's not even the original elongated Utah teapot. Yeah, there's too many faces for the original Utah teapot. Wasn't the original Utah teapot very low poly? Really low roly poly. I'm pretty sure it was really low poly because 1,000 faces and shit. Come on. 6,320 faces. Holy shit. So how are we gonna start, parsing this shit? How are we gonna start parsing this shit? We need to slurp this thing into something, basically. We need to slurp it into something. I want to kind of reuse my slurping function from before, but it's really difficult to how to say that, to extract it, because it depends on the global variable. Global variable makes it difficult to reuse the code. Oh no! The CS professors were right. I was wrong all along. Oh my god, what do I do now? I just use the global variable. I cannot reuse the code. Well, we can just decouple it from the global variable. That's how we can do that. So let's create something like a region, I suppose. Type def struct region, right? And it's gonna be something like data. Just to see the scale, one day programmer deleted his leap to add zeros before number, and it was because lots of projects. How one programmer broke by deleted tiny piece of code. It's a left pad. I mean, it was a long time ago, wasn't it? I think. Or something else. Is that yet another left pad thingy? I don't think so. Yeah, it's an old one. Okay. Alright, so this is gonna be the region capacity, and here's the region capacity. To be fair, what if I want to have regions of different capacity and stuff? Not for now. So this is the size, and then we also have a pointer to memory. So, and we can get rid of that. So this one is going to be a region, right, which accepts region. So I need to refactor my allocator. So this is going to be a region realloc, and it's going to accept the region realloc. It doesn't support free. I think the original Utah pod used the Bezier curve, so you could actually render it with the fidelity of your choosing. Oh, nice. Oh, that's pretty cool. Okay, so that makes sense. Cool. As far as I know, they still sell them. Buy Utah teapot. Yeah, I also know Bezier curves. We also implemented them. Oh, there you go. I could have just bought it and traced it myself. There we go. So here's the Utah teapot. What does it say? I have no idea what it says. What does it say? I'm sorry. Anyways, so here's the region. Oh my god, the fuck. Alright. So I kind of want to move the region related stuff to a separate module, so it's a little bit easier for me to work with it. So we're gonna call it region. It's gonna be if and def region.h, right? It's define, and it's gonna be end if. So let's move everything there. I want the region to be sort of customizable as well, but yeah. Region capacity, if it's gonna be, oh yeah, so if it's a capacity, let's actually put it like this here. So region capacity, here we go. There we go. And let's introduce something like a region.c, and let's move all of these things there, right? So all right, so here's that, and let's also include region.h. So we have allocation and reallocation, and maybe it would make sense to have something like a region clean, which accepts the region, right, and just cleans it up. And cleaning up the region is essentially just setting its size to 0. Very straightforward. In the original main thingy here, what we're gonna have is region hot reload memory. Yeah, hot reload memory, I suppose. Or maybe hot memory. Yeah, I guess it's alright. So STB malloc is gonna use region malloc, and it's gonna literally use hot reload memory, so like a pointer here. So, and in here we're gonna also use hot reload memory like this. So let's also put it like that. Okay. So this is gonna be that, and this is gonna be that. Cool. So we're using hot reloading memory for everything, and when we're slurping the file, right, we're gonna accept the region into which we're slurping it, right? So that's the refactoring that we're gonna apply. That's the refactoring we're gonna apply, which basically decouples slurp file from this global variable. We still have a global variable because we need to customize the allocator for STB, but yeah. We'll see. So what do we have? A region. I need to include the region. One-man spam. Yeah, classic. So region realloc. What else do we have here? So a sister from SV. I think we also need to customize this thing. So this is going to be a region. All right. Sister from SV. Region. There we go. Okay, so another thing here is going to be region. There we go. Slurp file. So when we're doing that reload, it's going to be hot reload memory, right? So we do hot reload memory. SV from sister. Yeah, that makes sense. Anything else? Hot reload memory. We can even probably customize reload scene with that, but right now we don't need to actually decouple reload scene from anything. So yeah, so we're gonna just use hot reload memory. That was sure than was hoping for. Oh, I see what you mean. Hot reload memory. There we go. Memory size. Okay, so this is going to be hot reload memory size, and I think region capacity. So in a region, yeah, we have a region capacity. Do we have anything else here? So memory size, and then what we need to do region clean, and we're just cleaning up the hot reload memory. There we go. Is it going to work now? It seems to be working, but we also need to link that with the region. It's going to be src region.c. src region.c. It still doesn't compile. Unknown size. We need to include stdlib. It has to be included. Is it going to work now? It's almost working. Okay, so now we need to do the internal brain refactoring. Yes. Internal refactoring. So memory size has to be replaced with just a region size. So here's the regional size. Memory is going to be just region memory plus region size. This is the result. And then region size is going to be just edit region size in here. There we go. Do we have anything else? All right, next one. Memory capacity. This is the region capacity. Anything else? Error no. We don't have an access to error no. I'm pretty sure we have to include error no. Anything else? Memory alloc. Region malloc region. We're allocating within the same region yet again. And yeah, that should be okay. Oh shit, it worked, but we still have warnings. We still have warnings. Mornings, not mornings, warnings. Morning warning. Morning warning. Warning. I really like to pronounce that, I'm sorry. Also, we have some strange shit in here. So, because we're printing the generated normals, we don't have to Warmings. Okay, so that seems to be okay. That seems to be okay. And yeah, so we extracted our own region allocators, so limited region and stuff like that. So we can actually extract, for example, a slurping function, right? Slurp function. So it could be actually region slurp function. So region is not like proper memory arena, because proper memory arena is linked list of regions. We just only have one single region because we're not doing anything super sophisticated, right? So, and I think it would be kind of nice to move these functions into the region, right? Because they work with the regions, right? So let's actually quickly do that. We're also gonna have to rename them at some point. See, I'm refactoring shit. I'm slowly refactoring shit as the code becomes more and more sophisticated, complicated. We're refactoring shit. So what's going to be the next thing? It's region.c. Let's put everything here, and let's see if that stuff compiles. Let's see if that stuff compiles. It fucking doesn't. So because this kind of thing depends on string view, let's include sv.h. What else do we need? And what else do we need? And so this is the file. So that means we need to include stdio io. Oh yeah, all right, that looks good. So one of the things I also wanted to do, I wanted to rename them to maintain some sort of like a convention, right? So this is going to be region, a sister from SV, so, and also region slurp file, right? We're going to prefix them with regions. Okay, region.c. So this is going to be region slurp. Region sister from SV. Okay, so we'll have to do this thing. Region, this is gonna be the next one. Okay, so let's recompile it one more time. Region sister from SV. Region sister from SV. Region slurp file. Okay, region slurp file. Okay. Looks good. Cool. Now let's do a committee. So what we did here, we extracted the region, a region allocator, and yeah. So let's basically do that. Region allocator. Factor out region allocator. Let's push that right into the repo. Bye bye, useless pointer. See you around. So, okay, so this is going to be the second entry point, and I'm going to do it like that. So, what I want to do, I want to allocate some sort of a region, right? So, region, let's say teapot memory. This is how we're going to call it. This is going to be teapot memory. So we'll put it on a static memory. Put it in a static memory. So, and what we need to do here, first we need to slurp a file. So this is going to be a teapot obj. So in a model, where do we have a model? Yeah, so teapot obj file path. So let's actually set it like this. It's going to be models teapot obj. The first thing we need to do, we need to slurp this thing. Teapot obj content, right? It's going to be content, and it's going to be region slurp file. We slurping it into a teapot memory, right? We're slurping it into teapot memory, providing teapot obj file path, right? And if teapot obj content turned out to be null, that means we couldn't do that. We couldn't do that. fprintf std error could not read file this, which is a teapot obj file path. There we go. And then we're gonna crash with non-zero exit code. Okay, so we can also do something interesting, like printf read zu bytes from as, and this is going to be basically tport memory, memory size. This is how many bytes we read. Tport obj file pass. There we go. So can I now compile all of that and see what's going to happen? Let's see what's going to happen. And we read 210,695 bytes. I think I pronounced that number correctly. I don't know how to say numbers in English. I'm really sorry. No, I won't give you back them. I'm sorry. They're mine now. So so what we need to do now, we need to turn this into an SV, I suppose. Let's do something like SV from sister, right? So this becomes string view data. No, right? Is it gonna work? Still works. Cool. So now we need to start iterating everything by lines. Probably. Thank you for bike shedding. That I could have fixed it like later anyway. Literally, thank you for nothing. So count greater than 0. And now I need to recover my mental model of what the fuck I was doing. Okay. String view is SV chop by delimiter to object content, and so we're gonna chop it by a new line. I'm gonna start banning people for this kind of shit, okay? Calm down, everyone. So count. It's gonna be 0. So now we're gonna print. We're gonna actually increment count. Right, read bytes and ZU lines. Count. There we go. Okay, so this is 9966 lines. So we managed to split everything by lines, which is nice. So now we need to learn how to ignore the comments. We implemented that many times. SV chop by delimiter. So we're chopping by the comment line, right? Chopping by the comment line, and we also do SV trim. SV trim, and this is going to be the new line in here. There we go. So without any comments and shit like that. And we're only going to handle it if count is greater than 0. If count is greater than 0, right? So we're only going to handle that. So, and the next thing we want to do, we want to extract the key. So whether it's F or V, right? Whether it's going to be F or V. And we're gonna do that by SV chop by delimiter, so it's gonna be line but with a space, right? So and then we're gonna have something like switch, actually not switch, if SV equal key SV V, we need to handle it as a vertex. If it is something else, right, we have to handle it as a face. Right, something like this. So this is what we're doing. So within a single face, we're gonna have other things like X, Y, Z and whatnot. To be fair, parsing 3 floating points would be easier with str2d. But maybe not. We'll see. We'll see. So I want to throw some sort of an error. I'm not sure what kind of error to throw. But I think we need to keep track of the line number. Plus line number. Fprintf is going to be std error. We also have to do like this thing. Error. Unknown obj key. I'm not sure if they are called keys. By the way, is there any name for them? Okay. Object file format. How do you call these things? Like directives? Keys? What are they? So it's simply the format that represents namely the position for each end faces. Vertices are started clockwise, so okay. How do you call them? Anything an object contain freeform curve phrases. The most elements are elements. I guess it's kind of a lame name for this thing. Okay, unknown obj element. It's a very lame name. Don't like it. Alright, so here we're gonna have the tpot obj file path. So then we have a line number, and then we have the key itself, but we have to rename it to element since we're following this kind of convention. And yeah, I'm gonna put it like that. So key and cool vertex face. Epiku. I wonder if I'm pretty sure 1 megabyte of memory is not going to be enough for us. I'm pretty sure about that. We'll probably have to allocate 69. Yeah, originally we had 69 megabytes anyway. Yeah, so let's actually pre-allocate 69 megabytes. So are we gonna like, count them first? And probably not. So we can pre-allocate the required amount. Tpot. So we have 3,644 vertices and even more faces. So, all right. So let's define something like tpot vertices capacity, and it's going to be 4,000. Let's actually put 4,000 in here. And tpot faces capacity. So, and how many of them do we have there? Let's put 7,000. Okay, so this is going to be 7,000. So tpot vertices, and so here is the capacity, and the vertices are three-dimensional, if I'm not mistaken. Yeah, they seem to be three-dimensional, so we're gonna put v3 in here, and I'm pretty sure we don't have a three-dimensional thing in here. We don't have a three-dimensional vectors right now, but we'll have to introduce them at some point, of course. We'll have to introduce them. And for the faces, oh boy. All right, so it's probably going to be just an integer. All right, tpot faces. All right, tpot faces. And to be fair, you know what? We're not going to do any major transformations, so I'm going to actually store it as v3 compt. Right, so I think it's going to be easier to work with that. And this is the tree vertices, right? So there we go. Looks good to me. So I'm pretty sure we can just put that into the like OpenGL buffers, and it will just accept all of them. If I understand correctly. Alrighty. So how everyone's doing? Does anyone have any questions? Hmm? The reference indices can be negative too, to index the last 3 with -2, but that should be irrelevant for the teapot. And why did you tell me that then? Cool. Do you gonna use indices? I don't know. Maybe. Do you plan doing something with 3D? What do you mean by something? Do you mean my game, or... I'm already doing something with 3D, so isn't that enough? So I literally did something with 3D. Well, I mean, you can see that, but... Alright. Okay. So I'm thinking what would be the best way to parse all of that. Just split everything by elements and just fill them up with the components in here. And also we need to keep track of these things. Size T, pot, vertices, this is size. Right. So this is not 5. Oh my god. Faces size. I'm gonna implement smooth lighting. Why the fuck do you think I'm trying to load teapot? Where have you been? Okay, I'm gonna ignore this kind of stuff. I'm gonna ignore questions related to something that I already explained in the past, because I mean, so it's a waste of time. Alright, so we're gonna be incrementing that. We also need to always assert that this thing doesn't overflow, because that's kind of dangerous. Okay, so I'll need to convert that into a line first of all. So first let's iterate through all of these things. So vector 3 components. So if we're incrementing this thing, I need to assert first of all that teapot vertices size is less than teapot vertices capacity. So this is what we're assuming here, and this is the second thing that we're assuming here, faces capacity. Okay. And after we processed everything, this size should be incremented by 1 for the vertices and for the faces as well. Alright. So this is the vector 3. So I need to chop off the component, right? SV chop by delimiter, and I'm chopping off this thing by the space. So here's the component, and I wanna right away convert it to maybe sister, right? Maybe convert it to a sister. A sister. Let me find. So region. Yeah. So you need to convert it to a sister here. So this is going to be teapot memory. Teapot memory, and there we go. This is a teapot memory. So then we have a component which is essentially that, which we can now convert into a float using str2f. There we go. Let's use str2f. And I'm gonna just ignore if it doesn't parse properly, because whatever. So it's going to be comp. This one is going to be null. And what I'm setting in here is teapot vertices. So this is the teapot vertices. The current vertex is that one, and the current component is this one. So yeah, that's kind of important. That's kind of important. So that should be all right. That should be all right. So for the faces, this one is very interesting. So we'll have to be iterating three vertices, right? So then we have a single component. This is the faces. Here's the faces, and with this thing we do A to I. There we go. So that's how we're gonna process all of that. So let's actually do the following thing. ZU bytes. Yeah, thank you. This one is important, I think. ZU bytes, which is teapot memory size. What else do we need? ZU vertices. Vertices. Okay. Teapot vertices size. Faces. Do we need anything else? I think that's it. Looks good to me. Looks good to me. Yeah. I need to recompile this entire thing. Okay, so what is going on here? Teapot faces. I see. Typo. Unused variable count. What do I use it for? It's actually kind of useless. Alright, so I read 3644 vertices and 6320 faces without using any library, by the way. Didn't use any goddamn fucking library. So we can take a look at whether it actually, parsed them correctly or not. So we can look at into that in a debugger. So do I actually include debug information? No, I don't. Let's recompile everything in here. And it was actually very fast. You see how fast it loaded everything up? Right, so I can even take a look at the time. So that's how quickly I can load everything into memory and parse it. Okay, GDB kditum. So let's break on main.c and it's gonna be main. So let's actually put it here 330. Right, let's just run it. So let's take a look at the teapot vertices, and so let's take a look at like two of them, maybe. Like first, -3, 1, 1. So we're looking at the vertices, by the way, right? So this is going to be a model. Yeah, -3. It's pretty much 1.8, and then 0, and another one. We can even take a look at like 3 of them. Yeah, it looks like valid data. This is the data that we see here. So I can even take a look at 10 of them. So and then I can take a look at the faces, right? Faces, like here is the 10 faces, first 10 faces, and if I go into the 10 faces, here they are. And I parsed everything super fucking quickly without using any library. Here it is, here is in the memory. I think programmers forgot how to program in 2021, because it's like you really need 41 lines of code to parse this kind of shit. So you don't need a library. You just don't need a library, even a header only one. It's such a simple format. Holy shit. What is going on in 2021 with this software development? I don't fucking know. I think this industry is doomed, literally doomed. I hope you're not being serious with us. I hope you're just trying to be funny joke. Faces can have more than 3 vertices, but they don't. Do you know what is our objective? Do you know what is our objective? Our objective is to parse one specific file. And as far as I can tell, in that file, we don't have it. Okay, so I'm gonna keep scrolling through the shit. Yeah. Oh, we can actually do that super easily. Let me show you. So let's try to do an assertion. So every time we parse the face, we're gonna make an assertion that the line count equal to 0. So we parsed all of the faces. So that's actually kind of important. I think this kind of assertion would be useful like in all of them. So let's see. And let's rebuild the entire thing. Didn't trigger. So we parsed everything correctly. There's no extra things or anything like that. Everything parsed correctly. Does anyone have any questions? Didn't even need Lex or Yak. Disgusting, right? That's why I'm unemployed, by the way. Faces have more than 3 vertices, then you're not using triangles to render. We don't have more than 3 vertices in the face. Calm down, everyone. Alright, so... So... how are we gonna put all of that? Where are we gonna put all of that? We can put this stuff probably in here. Yeah, I have an idea. So let's create a special function. So here's going to be teapot, and I'm going to turn this function into something like this. Load teapot. Right, it's going to be literally called load teapot. And maybe I should have not removed the teapot memory. There we go. It's going to be void load teapot. So this entire thing is going to just load the teapot into the memory. So after that, maybe it makes sense for me to clean the region of the teapot. Region clean. Teapot memory, but maybe it doesn't even make sense for me to even use teapot memory. Maybe I'm gonna just you know, use the hot reloading memory, because why the fuck not? I can just put everything in that, but maybe not. Anyways, so reload scene, and then we're gonna do load teapot. There we go. So let's see what's gonna happen. Control reaches the end. Okay, so everything loaded correctly. Everything loaded correctly, and in compilation I saw some warn. Not compilation, compilation, please. Alright, so clean, and this thing is not supposed to return anything. Emacs is so slow. Emacs is so slow. Okay, everything looks okay, more or less. By the way, oh, we also need to figure out the normals and shit. fuck. Yeah. So that one is going to be interesting. We need to figure out the normals. We don't have normals. Oh boy. So I need a way to disable this kind of shit. So as far as I know, normals, like you can derive them from the faces, right? Because by default, OBG uses counterclockwise order of the vertices, so we can figure out the normals from that. If I remember correctly, at least that's what they say in Wikipedia. At least that's what they say there. Also, so we're gonna have slightly different shaders for all of that, right? So this is sort of the main shader. Let's copy paste them into like teapot shader, right? So this is gonna be teapot vert, right? So this is gonna be teapot, and this is gonna be teapot frag, right? Here they are. So this is the fragment shader and a teapot. So right now we're going to only have, I guess, the position, right? So we don't really have anything else. We really don't have anything else. So let me get rid of all of that. And then we'll have to do something about this. So it's going to be UV, vertex, this is a camera position, normal, we're not going to have a normal. In terms of normals in here, this is going to be that. And I guess that's pretty much it. That's pretty much it. What's up, Odin? Welcome back. We're trying to load the Utah teapot into our engine, and we already parsed the OBG file. Isn't that cool? I think it's pretty goddamn cool. Maybe. I don't know. Maybe it's not that cool. Yep, teapot. Teapot it is. Alright, so I'm gonna actually use slightly different shaders in here. So this is gonna be a teapot. Oh shit, I'm already almost at the 4 hours mark, so I'm not sure if we'll be able to do much with the lighting, but at least we can try to lower the teapot and see if we even can do that. All right, so I want to make a small break. So it's gonna be 3 minutes. So, you guys have fun? Yo, just in time.
Sodding
Rolf.
boss.
Sodding Post, thank you so much for 14 months of tier 1 subscription. Thank you, thank you, thank you, and welcome to our epic OpenGL club. How about that? How about that? Thank you so much. People subscribe to me rarely these days for some reason. So the amount of subscribers actually dropping. Yeah. It's kind of strange. The amount of viewers, like on average, is growing, but subscribers is just going down. Everyone is back. Back. But that's okay. That's okay. Filthy. Somebody suggested an interesting hypothesis that... Thank you! Ellipse0934, thank you so much for tier 1 subscription. Apparently your first subscription. Thank you, thank you, thank you, and welcome to our OpenGL club. Somebody suggested a pretty interesting hypothesis that it might have something to do with COVID, right? So generally, right, more people stay home, but because of the COVID, maybe a lot of people lost their jobs, so they save money. So that kind of explains the situation, right? So the viewers are growing because people sitting at home, but the subscribers are, you know, going down because maybe some people just don't, their income has dropped or they lost their job or something like that. Thank you, Amapl. Thank you so much. They're just plebs and ban. Okay. So that's another explanation. Working from home, making procrastinating easy. Yeah. So it's kind of interesting. It's kind of interesting. So here is the mesh. Mesh. So what I was doing, so I'm generating the cube and I'm also loading the teapot. And I need to learn how to use vertex array object. Vertex array object. I think OpenGL val, because this is essentially what it is, right? Vertex specification. Because right now I just put the vertices into the buffer, and there's also like one single implicit vertex array object, and it sort of attaches to that, if I remember correctly, right? So vertex. Oh my god, let's actually read about that. Vertex array object is an OpenGL object that stores all of the state needed to supply vertex data, with one minor exception. It stores the format of the vertex data as well as the buffer objects, providing the vertex data arrays. Know that VIO do not copy freeze. Oh, I think I remember how you do that. You probably create a special kind of buffer for array indices. Yeah, boy. What is this? 2016? Why I keep saying that stupid name? I'm sorry. So when you bind the buffer, so there's different targets. So you have array, element array buffer. Cooking boy. Why does it sound so funny? Classic voice line, yeah. Same 5 lines, by the way. The GL element array buffer. So what does it stand for? GL element array buffer. So when a non-zero buffer object is bound to the GL element array buffer, target the indices parameter GL draw elements, arrange elements. Yeah, and you have to actually draw, yeah, here it is, loading index buffer. So data size in bytes, and yeah, get buffer parameter IV, GL element array buffer. Okay. So here's an array buffer. We put all of the vertices there. All right. Vertex array attrib. So the texture coordinates. And then instead of draw, I think I'm using draw array, right? So I'm using GL draw arrays. And what I need to use instead, GL draw elements, right? GL draw elements and amount of vertices, and it will, I guess, work, which is interesting, but okay, good. So Render primitives from array data. So there's a mod. You can have several mods. Count the elements to be rendered. Okay. Type. Specify the type of the values in the index must be unsigned byte, short, or int. We're using int. Drops. What? Okay. Cooking grill. Yes. I guess we have to use unsigned in. Oh, frames. Oh, I see. Oh my god. Like, yeah, so the frames were dropping. Could you answer why C and C++ don't have byte primitives, data, time, and char used for those purposes? Thanks. No, I couldn't answer that question, sorry. Okay. So we can try to use some of that stuff, right? Array buffer, element array buffer. Okay, cool. So here we're loading the mesh. And that's probably okay. I'm gonna comment out this thing, and instead we're gonna try to load the teapot. Might as well, alright. If def cube, I'm gonna call it cube. So if def cube, everything related to cube is gone, and if cube, there we go. So we're not rendering cube anymore. So if I try to do this kind of thing, okay, so it doesn't work because vertex is undeclared, blah blah blah. And oh yeah, it actually complains about the new shader. Didn't I answer? Didn't I tell you that I cannot answer? Why do you copy paste the same question 2 times? Unless you want to be timed out. One more time and you timed out. Alright, so fail to compile the vertex shader teapot vert. Vertex undeclared. Okay, so that's very interesting. Why is it undeclared? Why is it undeclared? And teapot vert. Teapot vert. Yeah, so it has a. It used to have like this thing. Vertex. Yeah, it was like output. So let's put it somewhere here. So this is going to be the output, and in the fragment shader, yeah, we use that. We don't have UVs or normals or anything like that, but we'll need normals at some point anyway. So yeah, is it going to recompile? It still does not recompile. Holy shit. Okay, normal and declared, and okay, so this is the normal. Oh fuck. Okay, so let's actually include normal. That means in the teapot vertex, we'll have to set normal to something. So let's actually set it to, is it 4? Yeah, it's 4, let's set it to 0, whatever. So just temporarily set it to something, and what else do you want from me? Normal, oh yeah, it has to be out vec4 normal. Anything else? Anything? Oh, holy shit! UV is undeclared. Okay, this is so bad. Teapot fragment. So we don't have UVs, right? We don't have UVs right now, so we can set this thing to some particular color, right? So it could be vec4. 0. Let's put blue in here. Right, let's put blue. Right. Right, so we're not gonna have this thing. 20 seconds. So, and I don't even know the order. Okay, so 27 something. 20. Oh yeah, okay. Okay. Finally it compiles. Holy shit. Okay, so everything seems to be okay. Okay, nice. Finally something compiles. Finally something compiles. So we load the scene, then we want to load the teapot. Right, we're loading the teapot. After we loaded the teapot, I think we need to start doing the buffer shit. All right, we need to start doing the buffer shit. So we're gonna start with this thing. So yeah. We have to create array buffer for vertices. Enable vertex array. But first we need to generate it. Okay, so GL gen buffer. Oh shit, I really want a T. Want a T. Want T. It's not a verb. T is not a verb. Tea addict? No, caffeine addict. Who addicted to tea? Come on. Nobody is addicted to tea. Everyone is addicted to caffeine. There's no such thing as tea addiction. There's a caffeine addiction. Again, buffers. Okay. Right, so we need to generate a one buffer. Right, one buffer, please. So we're gonna call GL uint vertex buffer ID. So it's gonna be vertex buffer ID. Teapot addicted to tea. GL bind buffer. GL bind buffer. Vertex buffer ID, and actually we have to do GL array buffer. Yeah, we have to do GL array buffer. There we go. GL buffer data, GL array buffer, size of teapot vertices. Right, so this is the size of teapot vertices. Then we use the teapot vertices themselves. And this is going to be GL static draw. There we go. What's up, Thresh5? Have you exercised today? If you didn't exercise today, you're banned. So, did you exercise today? I'm gonna go to the kitchen, and if you didn't exercise today, you're goddamn fucking banned. Straight up. All right. What's up? Back. So then we're gonna have a vertex index, I think that's how I called it. Yeah, it was position index. Okay, let's actually call it position index then. Position index. Here is the position index. Then we have to enable vertex array buffer. So this is going to be position index. So when we're doing this shit, right, we're also enabling vertex array attribute pointer, and we have a bunch of indices and stuff like that. So this is the index buffer. Array element buffer data. I guess for the elements you do like the same shit, but you also have to connect a buffer parameter I. Fuck, this is actually kind of interesting. So that's interesting. Very, very interesting. Buffer subdata. Date subset. No, this is not what I wanted actually. This one. John's data is okay. Return parameter of a buffer object. I don't think that's what we need. I suppose it's gonna work automatically, right? It should, yeah, it should work automatically because you have target for the buffer array, for the elements, and so on and so forth. I think it does kind of make sense. All right, so and then we have the GL vertex attribute pointer. Attribute pointer is gonna be position index, and we have v4 components, right? So here's the v4 components. Then we're gonna use GL floats, GL float, and GL false, 0 null, 0 null, 0 null. So this one is kind of difficult. This one is kind of difficult because I'm pretty sure, like, if I fuck up, I won't be able to know like how to fix this shit. So that's why I'm a little bit scared. That's why I'm like sort of hesitating to do anything. All right, so let's introduce something like index, maybe face buffer ID. So this is gonna be face buffer. GL gen buffer buffers 1. Face, maybe it should be called faces. It's already called vertex buffer ID. Okay, so whatever. GL bind buffer, and we have to bind it as element array buffer. Element array buffer, I think. Yeah, element array buffer. Element array buffer, phase buffer ID, there we go, and we need to associate the GL buffer data with it. GL buffer data. Data size in bytes, and yeah. GL buffer data. GL element array buffer, size of teapot faces. Set of teapot faces, and this is a teapot faces GL static draw. And I don't think we need to associate anything with the vertex attribute or anything like that. I'm pretty sure we don't have to do that. Yeah, and it could be even out. It could be even somewhere here, right? It could be even somewhere here. Enable vertex attribute array. Vertex attribute array, and then we associate. I need to understand how it's done actually. I need to understand how it's done. Alright, so here's the vertex attribute pointer. How does it work? Specifies the location and data format of the array of generic vertex attributes at index to use when rendering size. So if non-zero named buffer object is bound to GL array buffer, is treated as byte order. Okay. What about how does it work with the element array arrays? GL element array buffer. Okay. I guess that's how we have to do that. I think we have to move it like completely outside in here then, right? If we wanna do it like that, right. Something like this. Something like this. So because this is a completely different way of doing all of that, because before all of the vertices were located in a single buffer. But now we have two buffers for the vertices and then for the faces, so there is an index buffer. And I do know that OpenGL can work with this kind of stuff. As a matter of fact, I already worked with this kind of stuff, but I forgot how to do that. So, and I may have trouble troubleshooting that. Classic. Destroy computers, oh my god, thank you so much for 22 months. For 22 months of tier 1 subscription, it's almost 2 years. Thank you so much, and welcome to our OpenGL club. Thank you so much. Alright, I'm a little bit hungry already, and I'm a little bit nervous that it's not gonna work, and I'm gonna spend too much time troubleshooting it. It's just gonna be really painful. Oh boy. So, and how many vertices I want to actually draw? Well, I'll have to draw element array, right? So I need to double check if I did everything correctly. So here's a vertex ID, teapot vertices. I think that's okay. So I also bind it to element array buffer. Everything's okay here, and then I enable the vertex attrib array thingy. So the position is 0. And it's gonna be v4 components. Everything looks okay. So these are GL floats and stuff like that. These are GL floats. And wait a goddamn second. Oh yeah, okay. So I need to take GL draw elements instead of array, right? GL draw elements. Let's see. GL draw elements. Okay, so we're gonna have mod. We're definitely gonna have just triangles, right? Just triangles. So draw arrays. We'll draw that. GL triangles. So here they are. So then the count, specified number of elements to be rendered. Okay, the amount of elements is going to be faces, teapot, faces count, size, yes, multiplied by 3 vertices, right? So this is basically how many of them we want to render there. The type is unsigned int, I suppose. Yeah, since they're all positive, it doesn't really matter that much. The pointer to location where the indices are stored, I think it's an offset, right? So that means I can just put a null in there, right? So there we go. Specifies a pointer to the location where the indices are stored. I'm pretty sure. Draw elements. Is there any example? So there should be example. Yeah, you can put a null in there. You can put a null in here. So we assign that. Okay. Oh boy, oh boy, oh boy, oh boy. I'm really scared because it might not work. So it should be like very bluish. It should be bluish teapot, if I understand correctly. And it didn't work at all. Didn't work at all. Like at all. Boy, boy, where is my soy? Yeah, didn't work. Stream is lagging? Really? That's very strange. Is it really lagging? Could you please tell me, is it lagging right now? Is it lagging right now? Because I didn't feel any lag. Okay, nobody's answering. It lags when you open... Is it lagging right now? Right, like, here it's opened. Is it lagging right now? Yes, okay. Interesting. Okay. Why would it be lagging? Is it because we have too many of this? FPS was like 25. Okay. I didn't see anything special. I need to understand if everything loaded correctly, because it doesn't even say that there's something wrong. That's what's interesting. It doesn't even say that there's something wrong. So we have to troubleshoot like very slowly and very painfully. And I really hate that we have to troubleshoot like that. Okay, so the way we can try to do that, right? So we'll have to start with like, oh my god, it's actually, I think, lagging a little bit. Music is also too loud. Everything is against me right now. GL position. So GL position, and it's not GL position. And what I'm trying to do here is, where is the vertex? Okay, so here is the vertex. We have, it's actually called position, I think. It's a vertex position. Vertex position, okay. Oh shit. Do you see that? That's very interesting. All right, so we're passing the vertex, but so it's doing something. It's doing something. It's probably fucking up the encoding, but there's nothing much you can do about that. All right, so in a fragment, why is it green though? In a fragment. So we have this thing. Okay, so let's actually try to do a very stupid thing. So where we have a fragment color set to... Oh, this is because I set it to green specifically. Okay. It's just green now. Everything is just green now. Alright, that's pretty cool. So we have something. We have something. Cool. So we're gonna start with the camera. So first I need to define this thing. It's gonna be like this. So it's gonna be like that. So then we're gonna have a camera. So here's the camera. So I'm gonna probably remove that. So in the model in here, all of them are like, yeah, the values are very small, so we'll also have to blow them up appropriately, but we probably don't have to adjust anything. Right, so what we're starting with, we're starting without any translation, right, and yeah, we're gonna just start like this. So then we're gonna have a camera position, so here's the camera position. And then we're gonna just start with... Okay, so here's that, here's the camera position. Here's the camera position, GL position, and we're gonna get rid of the color in here, and normal is gonna be that. Okay, so didn't break, as far as I can tell, didn't break. Cool. So let's try to maybe translate it a little bit far away. So we're not going to modify X and Y. We're going to try to modify only Z, and let's just put it a little bit further away from us. What about 75? We're not doing any perspective also. So does a camera even apply? Camera is applied, yes. So we just use the camera position. And what if I put minus 25 in here? Okay, that's cool. Minus 30, how about minus 30? Alright, that's pretty epic. 40. So we're moving it away and everything is completely broken, which is nice. I wonder what the fuck is going on. So do we have any negative indices there? Maybe. Okay. Alright, so there's no negative things in there as well. So there's only that. Interesting. But something is completely fucking borked. Something is completely borked. But what exactly? I don't know. But we're trying, desperately trying. Oh, but what about minus 200? Is it gonna work? It's no, it's not working. So the data is completely corrupted. Maybe we read it incorrectly. Who knows? Did I load the teapot? Did I load the teapot? All right. So we're loading it into the memory. Teapot vertex sizes. Did I even increment? Okay, so I do increment this thing, then increment the faces. Oh boy, I don't know. So let me take a look. Have we checked that OBJ itself is fine? How do I check that? Open it in Blender. I can try to open it in Blender. So first of all, let me close everything. How do I check that it's fine? I have no idea. Maybe Blender can show me something. So the people say there was an error, right? File is not open, default sim instead saving. Okay. Ooh, OBJ file viewer. Can I just open it here? I remember the last time I used this thing, it didn't really work well. I have to, yeah, okay, so that worked. That's actually worked way better than I expected. Yeah. Okay. So maybe I'm fucked up the parsing. Size of part? What are you talking about? You don't make any sense. You're not helping. You might be spotted the error, but you're incapable of actually explaining the error to me, so you're not helping. Oh, shit. So by saying something, oh, it's the size of part. You know how many size of keywords I have in the source code? You're not helping, you're wasting my time. So I might as well quite like faster go through the code myself. Whatever. All right, so here's the faces and this thing. So here's the faces. We're loading the model. So this is already ignored code. Before components, wait a second. Aha, I see. Vertex teapot vertices. So we use v3. Okay, so v4 comps. If we try to change it to v3 comps. Yes. Okay. So that's cool. So let's close that. I'm really sorry. It's a really unfortunate time. Really, really unfortunate. I'm really, really sorry. And now I have to look like an asshole. Three vector three. Vector 3 element. Where was the vector 3 component? Vector 3 component. Vector 3 component, I didn't see it. v3 comp. V3 comp. Yeah, so it works. Like, for fuck's sake. So vertex. Now, if I don't move that away. Yes. So let's actually start moving it away a little bit. It doesn't change anything. Okay, so it starts doing things. Okay, so this is already a little bit better, but not really. Really not better. So this looks really strange, but yeah, so essentially I was interpreting all of that as yes, I was interpreting all of that as four-dimensional components. All right, so okay, that's actually fine. I have to do v3 comp. So v3 comps. Let's use v4 comps. Right, so let's just keep using v4 comps. And in the teapot, vertices. In the teapot oh my god, where are they? We're gonna use v4. All right, we're gonna use v4. We're still gonna iterate through the v3 components. We're gonna set the fourth one to 1 always, because it's important for the perspective and shit like that, if you know what I mean. Right, so I need to double check if I didn't make any mistakes. So this is v4, this is that, and when I create v4 components, it's gonna be that. Hopefully that will do the trick. And we're gonna interpret everything correctly. All right, so we need to rebuild this entire thing here. And yeah, so it didn't help at all. Didn't help at all. Oh my god, I'm so molding. Holy shit. Thank you, Destroy Computers, for how many subs? For 20 subs. Thank you so much. Thank you, really appreciate it. I'm really sorry that you just gifted them at a very unfortunate timing. It was very unfortunate timing. I really apologize for that. Because like I was in the middle of like almost finding an error, and it just snapped me away from the ability to even remember what the fuck was the problem. But thank you so much for 20 gifted subs. I do realize that I sound like an ungrateful asshole. Maybe I am. Maybe I am an ungrateful asshole, and I should be doing this as a job. But thank you so much. You changed it in the generate cube mesh place, not where you... Right, probably. I don't remember where... What do you mean by that? I don't even touch generate cube mesh. Oh, I see what you mean. Yes, okay. Oh shit, I need to... I don't want to remove this thing. I guess I am just an ungrateful asshole. Yes, I'm an asshole streamer. There's nothing I can do about that. For me, programming is more important. I'm really sorry about that. So it is what it is. Okay, so here's v4 components. And I did change everything accordingly, I'm pretty sure. Depot vertices. Okay, so before components, so we actually do 3, and no, I changed everything. It doesn't work. Oh, it doesn't work. And chat is completely unhelpful. I just should have stopped streaming. Okay. I think we use a similar approach in the Boomer. So I want to take a look at the Boomer code. Why do we bind it all the time? It kind of looks very unnecessary. Okay. So here we explicitly generate vertex array thingy, but I'm not sure if it's really helpful to do it. So bind, because you have an implicit vertex array object anyway. All right, so we bind the vertices, right? So we bind the vertices like that, and we associate the this stuff. Then element array buffer. So we compute the stride. I think stride is particularly unimportant, so it's not really important. So then we enable everything. So yeah, indices is just, yeah, indices do make sense in here. I do exactly the same thing, I'm pretty sure. I do exactly the same thing. So and then when I draw everything, GL draw elements, right? So triangles, I draw 6 of them. And interestingly enough, right, so I have an amount of faces, and then I just multiply it by the 3 vertices. So I'm drawing this stuff. Wait, really? What the fuck? What the fuck is this shit? Who invented that format? I'm gonna find this person. Who invented this shit? Developed by Wave Technology. Who personally invented within waveform technology? I want to know that fucking person. I'm just joking, of course. Holy shit. And I also acted like an asshole to destroy computers because of that, and now I feel bad. I'm such a bad person, holy shit. Okay. I wish I could be better, wish I could be more patient, but I cannot. Too impatient for all of this shit. Shouldn't be not a programmer at all. Okay, so that looks okay. Well, and of course then it just goes away completely. So that's totally fine. We don't have to really translate anything here. Right, so let's just scale this entire thing to like 25 by 25. It's gonna be very big, right? It's gonna become very big. And then we're gonna apply perspective, right? So we're applying perspective. And now, once we apply the perspective, we wanna actually slightly move it away, I think, and I cannot see shit though, but this is probably because it's gonna be something like this. So let's actually move it away even further. How about 100? Now we can see it, which is actually kind of pogue. Yeah. Holy shit, it's big. It's very big. And I actually kind of like it when it's big, because in the perspective it looks really, really cool. Not gonna lie. So, yeah. So, is the stream still lagging, by the way? Because we are rendering like thousands of triangles and shit. Let's try to rotate this thing. Yeah, we're rotating it around its axis and stuff like that, so it seems pretty cool. And now we can also rotate it around the Z. So yeah, that looks pretty awesome. Okay, so what if we make it a little bit closer? Developer without the fuel, you're spitting out nonsense. Holy shit. Alright. Because it's perspective projection. Because it's a perspective projection, that's why it looks so hilarious. We can actually move it away slightly, maybe like that. Okay, so when we're rotating everything, so we can actually multiply the rotation to make it a little bit faster. It doesn't really have like a big nose. It's just like this is because of the perspective projection. Anyways, so here's the thing. We need to have normals to even render anything, right? So we need to have normals to even render anything. So where can we get the normals? We can pre-compute them. I'm pretty sure we cannot pre-compute them in a shader. We have to pre-compute them on a CPU. So the amount of normals we can have is per, I guess per vertex. Per vertex. Okay. All right. So here's the faces, and for each face, all right. And we're also drawing elements, right? Per vertex, yes. So, I'm not even sure. We can do it like that, I suppose. Teapot normals. Teapot normals. So we're gonna have the same amount as like vertices capacity. And to be fair, Oh my god. How do we pass the normals to the shader? How do we pass them to the shader? Ooh. I don't know. Can you... I guess... Oh my god, I don't fucking know. Together with vertices. We're reusing the vertices. We're actually reusing the vertices. Okay, I won't be able to figure it out. So, this is the result of today's stream. So, okay. So on today's stream, what did we do? It's actually quite important. We managed to load a pretty big model, like thousands of vertices and stuff like that from OBG. I wish we could implement the lighting for it, but it will probably take too much time for me to learn. Like, it requires completely different approaches that I already have in the code. And on top of that, we implemented a very simple lighting, right? We implemented a very simple lighting. So yeah, so we have this fog and lighting and texturing, and we actually fulfilled all of the objectives that we had for OpenGL 3D series. We generated a cube mesh from scratch. We rendered the cube mesh with a perspective projection, textured the cube, implemented the fog, and simple lighting. I guess we achieved the goal of Friday topic. Yeah, so that was the goal of Friday topic, is to go through all of these points, and plus we managed to load up the teapot, which is kind of cool. I think I'm gonna call it a success. Going even further, it's kind of like outside of the scope of this project. So from this, it would make sense to start a completely new project, which would be something like 3D engine or 3D game, simple 3D game or something like that. So yeah, that was kind of cool. That was a pretty cool journey that started on last week Friday. You can find the source code of this entire stuff in here. I'm gonna commit the teapot stuff as well at some point, but I want to just, you know, clean it up slightly. Slightly cleaned up, so you can switch between the cube mode and the teapot mode and stuff like that, but all of that is gonna be a little bit later. Unfortunately, that's it for today and for this series. This is not the last 3D OpenGL stream, but it's a last stream in series of Kitito. It's time for me to go, boys and girls. It's time for me to go. Thanks everyone who's watching me right now. I really appreciate it. Have a good one. And I see you all tomorrow. Tomorrow we're gonna continue according to the schedule, so it's gonna be a virtual machine in C, right? Check out our schedule page for more information on different projects we're working on. Check out our VODs channel. I'm gonna upload all of the VODs for 3D OpenGL series in a separate playlist, so follow that playlist. We'll already have a first episode there. And check out our Discord server for offline discussion with the community. And yeah, that was fun. I really enjoyed it. Thanks everyone. Love you all. Mwah.